One, two. Okay, there we go. Fucking hell. Sorry about that, guys. Evening, guys. Start that again. Just pouring myself a bit of cheeky Pinot Grigio. How's it going? How do you guys all like the new scheduled stream? Being that you get to know when I'm about to go live like a few hours in advance. I haven't been doing that before. This is the first time I did that. I didn't actually know how to use it. Call me a YouTube guy. I don't even know how to use the scheduled stream button, but there we go. Works now. I think it's probably better because you get to know when I'm going live rather than it just like missing the notification and all that stuff. But yes, how's it going, guys? Thanks for letting me know there was no sound. Stupid OBS deciding to change the settings by itself in between days of streaming. That's always good, isn't it? I noticed actually, I watched back a few seconds of my stream the other night, and I noticed that actually when I switch to this camera, the audio changes slightly. But no, it was definitely different. But I noticed on the stream the other night, between cameras, the audio seemed to like get louder or quieter depending on what camera I was on. But it seems to be okay now. RTA mic, yeah. But this evening, if you weren't joining the live stream last night, so last night in the live stream of STREAMMAS Day 4, we repaired a couple of small bits, a Pioneer 9601 mono and an old school power acoustic Class AB mono. And while we were repairing the power acoustic Class AB mono, my soldering iron tip decided to completely fall apart. And these soldering iron tips are out of stock, were out of stock for a long time in the UK, and shipping them from overseas was really expensive. So I was just kind of trying to hold on to this soldering tip for as long as I could, but it's given up now. So this evening I'm without a soldering iron tip and I don't have a backup soldering iron. So instead, what we're going to be doing is we're going to be talking about how the freaking hell does Class D amplifiers work, and we're going to be showing you exactly how a Class D amplifier takes an analog sine wave, how it converts it into the square waves that you see and why it does that, and then how it creates the sine wave back at the speaker terminals again after being turned into square waves and all of that jazz. The PCB cam is louder. It's the same microphone. Hang on a minute. So just looking at my OBS here, so you can see here, if I show you my OBS screen real quick, you can see here that we've got the RTA mic is just here, and then all of the other all of the other things, it should be the same. Hang on a minute. Okay, so this one's up at 0 dB. Okay, let's try this one. This one is also up at 0 dB. This one is also up at 0 dB. So why is that louder? It doesn't make any sense. Why would that be louder? Because it's the same goddamn microphone. And there's no other audio sources on here either. Properties, filters maybe? Filters, gain, off. Nah, I don't know. Doesn't seem to make a great deal of sense to me. I'll look at it later. I can't be asked. It's the same microphones. It doesn't make any sense why it would be louder on one and not the other. Maybe if I just move my RTA mic up to the top on every single one of them. Maybe that's better now. Is it the same now? I don't know. Anyway. The cam closest to the amp gets louder. That's really strange. Why is that? Fuck it, I don't care. So, anyway, before we look at a few things... yeah. I have got this Pioneer back out with the hope of showing you, using this amplifier to demonstrate how Class D works by showing you some of the waves and following the audio through it. But because this, I just realised, because this is a 2092 driven circuit, it's a little bit different. And I think the IRS 2092S, I think, actually takes the sine wave audio input and does all the conversion in the chip, which is not what I wanted. I wanted it to do it outside of the chip so I could show you. Let's just take a quick look. IRS 2092S. Let's just take a quick look at this chip, and let's just see whether this has the ability for me to show you what I want to show you. So in minus... No, see, this doesn't do what I want. See, okay, so the amplifier that I got out to show you how Class D works isn't ideal, because inside the IRS 2092 chip, we actually have the whole conversion from analog to digital going on inside the chip, which sucks for showing you how it works. So I'm going to try and dig out another amplifier. I think I've got a bass face DB 1.3 I can dig out that'll work fine. But before we look at the actual amplifier on the bench, we're going to be looking at a little bit of theory in form of a website. Now, if you've been following my channel for a long time, you will know that I highly recommend Perry Babin's Amplifier Repair Guide from bcae1.com, and I will throw people that way if they're looking to get into amplifier repair. However, that is not the only thing that Perry has done on the bcae1.com website. This website is an absolute goldmine, absolute gem of a place to learn about not just car audio, but also electronics in general. It's a fantastic source of information, and it is largely underrated, and people don't generally know about it, especially like the younger guys and stuff like that. It's quite an old-fashioned website, and it uses Flash and stuff, and it uses old school HTML. It looks really dated, looks like something from the early 90s or something, but it is a phenomenal source of information, absolute gigabytes worth of information here. And for today's lesson, I guess, if this is going to be a lesson, we're going to be looking at one of the free pages. So we're going to be looking at the bcae1.com website, not the Amplifier guide that's paid. We're going to be looking at some of the free content on the website because there is a fantastic demonstration. It's just easier for me to explain to you how Class D amplifiers work by looking at Perry's demonstration on the website. Let me just bring up a Google image real quick as well. Here we go. So this is the Google image that I wanted to show you as well. So let me bring this up first, and I'm just gonna, before I bring this up, I am just gonna answer some questions first as well. We're gonna do a little bit of Q&A in the live chat before I jump into this. Right, where's my chat gone? There it is. Does the camera have a microphone? Yeah, so the cameras do have microphones, but I've checked all of the camera microphones are off in the audio mixer. So yeah, there is no camera audio being picked up. It's just RTA mic in my OBS screen here. Yeah, I'm going to grab the bass face to show you how Class D works. But yes, BCA is a fantastic amount of info. The website, here we go. I'll show you the website on the screen. this is the website here. Let's make sure that's showing. Yep. bcae1.com. Guys, bookmark this website. Absolutely phenomenal website. Let's just show you the main website. So the main website, bcae1.com, looks like this. Okay, and you need to view it on a desktop computer. I can't stress this enough. If you're trying to view it on your phone, it's not going to work properly. I highly recommend using Google Chrome, and in order for the website to work properly, you need to enable Flash Player. So in order to enable Flash Player, you need to go to settings. You need to go, I think it's to like advanced, and then what is it? Privacy, maybe, accessibility. Here we go, privacy and security, and then I think you need to go to site settings, perhaps, and then you've got, there should be a Flash Player thing down here. Here we go, Flash. You need to go to settings, privacy and security, Flash, and you need to turn this on, ask first. Make sure that ask first is turned on. If you turn it off, it says block sites. Turn it on to ask first. Provided that that is turned on, wait, can I go back? No, open the wrong one here. Provided that that is turned on, ask first, then basically all of the things in this website are going to work properly. And you'll come across a part of the website that will say Flash Player needs to be enabled. Click on it and then click allow. You must view this on a desktop computer. So Perry's website, bca1.com, this is the introduction. Now down the right hand side of the screen, you have the contents, or the index, and there are just hundreds and hundreds of pages worth of phenomenal information about all kinds of electronics, car audio, how stuff works. It's quite dated, so a lot of this stuff is sort of relevant to like 90s, 2000s kind of audio systems, and stuff is a little bit different these days, some of the amplifiers and stuff like that, but everything is still completely relevant and gives you a solid base to work from in terms of understanding everything about car audio, how electricity works, how current flow works, audio output. So every single page just has tons of examples, pictures, flash diagrams. It tells you all about resistors, resistor markings, understanding what kind of different resistors do, like the different sizes, different types of resistor, when you should use each type. It's just absolute phenomenal source of information here. This isn't even the paid content, this is the free content. Tells you about MOSFETs, how MOSFETs work, field effect transistor. Tells you how to measure a MOSFET with a multimeter without needing a special tester. Tells you about op amps for the preamp section, TL772C and stuff like that. Understand how they work, inverting and non-inverting inputs. And it also tells you about PWM power supplies, which are used in every single car audio amplifier, and understanding how it creates real voltage from the PWM. Yeah, anyway, it's an absolute phenomenal source of information. I highly recommend that you check it out. And the example that we're going to be looking at today is one of the pages on Class D audio. Oh yeah, so the sweater. New Christmas jumper every day. I've got about 7 or 8 different Christmas jumpers. This is Toy Story themed. I saw this in Primark and I thought it was sick, so I had to jump on that. Really cool Christmas sweater. Who threw up on your sweater? Nah, man, this is a balling sweater. This is a sick Christmas jumper. Also, Christmas jumpers don't have to look good. They don't that's the whole point of a Christmas jumper, is that it doesn't have to look good. It just has to be like festive and usually very erratic and kind of busy and too many colours and shit. That's the whole point of Christmas jumpers, man. It's the only time of year you get to wear shit like that. Yeah, okay, right, so let's first of all then take a look at this picture here. So I'm going to just talk you through this picture real quick, because it might look a bit confusing at first. Maybe actually if I copy it into Paint, that might be wicked, so I can kind of draw on it. Okay, so in the blue line here is your audio wave. So this is what's coming from your head unit. Make sure you can see that. Yeah, this is what's coming from your head unit. Now, when you plug your RCAs into your car amplifier, the audio signal will go through all of the preamp section first. So it goes through the preamp section, it goes through the op amps, which give you control over gain, low pass filter, high pass filter, phase control, all things like that. And the preamp section is not only to give you some controls to adjust your audio levels, it also acts as a buffer. So it buffers this this signal so that your amplifier section isn't directly connected to your head unit. That wouldn't be ideal, especially in case of failure, and it also helps reduce noise and stuff like that. If your head unit was connected directly to the drive circuit of the Class D section, that's not ideal. Here's a quick tip for you. If you're ever troubleshooting an amplifier and you think that there may be a problem with the preamp section, on half-bridge amplifiers that have a slave input or a bridged input, you know, like a slave input, slave master, the slave input usually has a direct connection to the Class D to the drive circuit through one buffer op-amp. I think it just buffered once, but it doesn't change it at all. So if you're ever unsure whether there's an issue with your preamp section, you can try plugging your RCA into the slave input and see if you get audio, if you're not getting audio before. Just bear in mind that the slave input is very sensitive. It's almost like with the gain turned up to full, so make sure you feed it with a low signal if you're doing that. So this here is your sine wave coming from the head unit. Now, what the amplifier does, once it's been through the preamp section, it goes into the Class D, the drive circuit. This sine wave needs to be converted into pulses, or a bit like digital data, which is why you'll find some amplifiers, some Class D amplifiers, are marketed as digital amplifiers. Digital, to me, that gives off the impression that there is some data transmission going back and forth between like some kind of processor that's actually actively kind of changing the amplifier's characteristics on the fly. It's kind of reading data, and there's data in bits, you know, flying around. But no, Class D amplifiers are not. There's no data. They're only digital in the sense that the analog sine wave is converted into pulses that you could represent as ones or zeros here. So let's take a look at our blue sine wave here. What happens is the sine wave is laid on top of a triangle wave. See this big spiky red triangle wave? Now, what the PWM generation circuit does is it overlays the sine wave on the triangle wave, and then by a series of op-amps and resistors and capacitors and sorts circuitry, it will take a snapshot of what is inside this triangle and inside this upside down triangle and inside this triangle here and inside this upside down triangle. So basically between every gap, between every spike, of the triangle wave, every kind of bit in between the slopey bits, it takes a sample of this, and it says, right, okay, how much or how much of how many volts or something, how much of the audio signal is inside this little space here. And it's obviously inverted. So for this first one, okay, we've got the sine wave is coming up. So this is a rest. This is a zero here. So here we have a relatively sort of low voltage part of the sine wave. Okay, so the low voltage part of the sine wave here is represented as this, which is quite a. It's represented as 50% duty cycle. So okay, maybe I should explain a little bit actually about what the Class D thing is on the output section for you to understand that. Let me zoom out. Let me just draw something down here real quick, because that might look a bit confusing. You're like, okay, why is that little bit of voltage represented as a larger pulse? So in the output section of the amplifier, we already know that we have rail voltages. So I'm going to draw the rail voltages here real quick. So in an amplifier, you will have a positive rail voltage and a negative rail voltage, and that's what these sine wave swings between. Let's go right back to basics with this. So I'm going to draw the rail voltages real quick. We have positive rail up here. I'm going to draw that as red, and I'm going to draw negative rail. Oops, why has that changed? I'm going to draw negative rail as blue. Okay. And the sine wave, I'm going to draw a really sketchy sine wave right now using the pencil in black. That's not so bad. So basically, here's your positive rail voltage. Let's take that as 80 volts. This is a big amplifier. 80 volts plus 80 volts and minus 80 volts. 80 volts. So our sine wave swings between these two rail voltages. That's basically that dictates the limits of the amplifier. Now, if you've ever repaired an amplifier or looked at an amplifier's output section on an oscilloscope, which I imagine most of you may have, or you've seen me do it anyway, and this is it's going to take a little while to rub this out, you will notice that on the outputs of the MOSFETs, the actual thing that has the audio on it, there's a really, really big square wave, okay? And that's really important to understand. So on the output of the low side MOSFET, which is what's actually connected to the speaker terminal, you have a square wave that goes up to positive rail, like this, down to negative rail, up to positive rail, and down to negative rail. And the important thing to understand is that the length of each pulse is exactly equal. So the length of this pulse is exactly the same length as this pulse, is exactly the same length of this as this pulse. So this is basic maths. So here we have, what happens if we have 80 volts up here? So this pulse up here is pulsing at 80 volts. Let's pretend it's right at the top. So this is an 80 volts pulse up here. Make that a little bit bigger. And down here we have a minus 80 volts pulse. Okay, now what happens if you do 80 volts plus minus 80 volts? 80 plus minus 80. You get 0. So basically, when the amplifier is idle with no signal playing, you are very used to seeing a big square wave on the output of the low side drain, which is like this, which basically is 80 volts on and 80 volts off at the same time, which equates to 0 volts on the speaker terminals. And we can see that by powering up this little Pioneer here. I'll show you that in person, just in case you forgot from my videos and my streams. I should probably just make sure this is all still working. Yeah, okay, so I'll point this out on the amplifier as well, just as we're doing it. But I'm going to show you on the Pioneer, I'm just going to really quickly show you on the Pioneer the output, the MOSFET drain, which is what we're showing here on Microsoft Paint. Plug it in, turn the amplifier on. Boop. There we go. So, the rail voltages are plus 46 volts and minus 46 volts. See that there? Minus 46 volts here and plus 46 volts here. And on the outputs, on the actual output of the audio, the thing that's outputting audio, there is this, which is a square wave that rides between positive rail and negative rail. And so what we have here is we have plus 46 minus 46 equals 0. So therefore, if I probe the speaker terminal, we have absolutely 0, because plus 46 minus 46 equals 0. Okay? Now, how the hell do we make a sine wave? Well, what happens then, instead of having equal lengths here, we shift that slightly. So let's rub this out. Let's just get the select here and select all this and get it away. So what happens instead then, if instead of having equal pulses, we now have a pulse that goes up to here, does a really, really big pulse, okay, comes down, and then does a really, really short pulse, and then goes up, and does a really, really big pulse, and then goes down, and does a really, really little pulse. Okay, what happens now? Well, now, you see, we have... get the text thing here. See, now here we have 80 volts up here for a long time. So in this kind of state, let's take this as one cycle, okay? In this state here, instead of having 50% of the time 80 volts and 50% of the time minus 80 volts, now we have for over like 3/4 of the time 80 volts and only a fraction of the time minus 80 volts. So that's now going to equate to a total of something more like 68 volts. Because here we're doing like, how am I going to do this with the maths? Because I did 80 volts minus 80 volts. So here we have like long time of 80 volts and a short time of off. So this is going to equate to a higher positive voltage on the speaker terminals, because we've got more of the positive rail here and less of the negative rail. Therefore, the output on the speaker terminals is going to be towards the positive rail. It's not going to be exactly the positive rail because we still have a little bit of negative here, minusing it away. So if there were no negative pulses at all and there were only positive pulses, then we would just end up with straight up 80 volts. Yeah, if there was no negative pulses. But because we have some negative pulses, we do the 80 volts minus a bit because of the negative pulse to give us a slightly lesser voltage on here. And the same goes if we do it the other way around. If instead we have our pulse here that is very, very short, up to 80 volts, and then we go down and we have a big pulse down here at negative 80 volts, like so, then the average voltage of this pulse is going to be more like negative 68 volts instead of positive 68 volts, because we've got more time spent down at the negative rail than we have the positive rail. Oh fuck! I didn't show the screen. I'm so sorry. I didn't show the screen. Fuck's sake. Sorry guys. This is what happens when I'm not looking at my OBS at the same time. So this here, big pulse at the top, small pulse at the bottom, big pulse at the top, small pulse at the bottom. This will equate to 68 volts plus, and then like a little bit down here. So this averages out at 68 volts plus because we have loads more of the pulse at the top and not so much at the bottom. So more of that positive rail is coming through than the negative rail. So, and the other way around, if we have the pulse like this, where we have more at the bottom and a small pulse at the top like this, then the average voltage of this pulse is more towards the negative rail, so like negative 68 volts. But when we're at 50% duty cycle, with half the time spent up at 80 volts and half the time spent down at negative 80 volts, then the average voltage on the speaker terminals is 0, because we have 50% of the time at 80 and 50% of the time at minus 80, we end up with 0. But when we have 90% of the time at 80 and 10% of the time at minus 80, we end up with a voltage that is nearer to 80. Yeah, that's a much easier way of doing it. Let's take it as percentages. That's exactly what it is. It's percentages. So 90% of 80 volts is whatever it is, I don't know, 60 something volts. And then when we do it the other way around, instead of that, we do like 10%, like 90% of minus 80 volts, you end up with minus 68 volts. So basically, it's the size of the pulses, whether it's bigger at the bottom or bigger at the top, that dictates whether we swing to a lower voltage on the speaker terminals or a higher voltage on the speaker terminals. Now, that's important to understand when you're looking at this. So let's go back to how the amplifier takes an audio wave and turns it into pulses. So here, it's looking at the bit of audio which is in between this pulse, this triangle wave pulse. Okay, now this is quite close to 0. So remember, at zero volts, which is the middle of this sine wave, which is 0 volts, we'll get 50% duty cycle. So we'll get an equal pulse of positive and negative. But because we have a little bit of audio here, this causes the pulse to become a little bit shorter. Now this is flipped the other way around. So as the sine wave goes up, we flip it in polarity. So just imagine this is flipped around the other way. Maybe I'll flip that the other way around. Flip horizontal. There we go. That's potentially a little bit easier to understand. Maybe not. I don't know. Or is it doing it from this one? Hang on, we've got a bigger. There we go. Bigger pulse. Yeah, so it's just flipped. It's just flipped the other way around. It's just flipped upside down. Maybe I can flip it upside down. Maybe I did the wrong one. Flip vertical. There we go. That's what I wanted to see. I just flipped it the wrong way. So as you can see here, with the biggest bit of audio, here we go. So a little bit of audio there. We get more like 50% duty cycle. And as higher voltage audio comes in on the RCA signal, as the sine wave reaches higher, this triangle wave is looking at the amount of voltage in between the steps here, and the more voltage there is in between the steps, it's converting that into longer and longer pulses on the positive here. So that's then going to equate to more positive voltage, and then back down at 0 volts, which is like around here, we have a 50, but almost like pretty much 50% duty cycle again here. See here, this bit is like 50% duty cycle, so 0 volts, which is pretty much where the sine wave is at 0 volts here. And then when the sine wave swings to negative rail, we then have much more duty cycle down at the negative rail, like this. So that's how the amplifier is turning the sine wave into pulses ready for the Class D output section. It's just listening to the sine wave, overlaying a triangle wave over the top of it, and then it takes a snapshot of the voltage in between each pulse of the triangles, and then the amount of voltage that's there, it then creates a length of pulse dependent on the amount of voltage in between each of these triangle spikes, which gives you a PWM version, or a digital version of that sine wave. You can see it here, voltage goes up, PWM gets closer to the top, voltage goes down, PWM gets closer to the negative rail here. So that is the sine wave on the PWM, like that. So all that the Class D section does, it takes that PWM, it takes that those pulses that it's converted from the sine wave, and then it gives them the very short kind of term way. It then gives them to MOSFETs, which are like switches to turn on and off. And so the MOSFETs, like we've shown here, have this great big square wave on it, which is 50% duty cycle at all times. Like this, okay? So there's 0 volts average between that. Now, if we apply a sine wave, watch what happens to that big square wave. Let's get my RCA here. Get my RCA. We've got a 47 Hertz sine wave going. Maybe if I can do it a little bit slower, we can maybe see. How do I get it a bit slower? Maybe adjust the frequency slightly. I'm going to go for a low frequency so we can try and see it happening like really good. There we go. That's a nice frequency, hey? Okay, cool. There we go. So you can see here with the sine wave is like this. Okay, that's our sine wave that's coming out of the amplifier on the speaker terminals. And on the FETs, we have this varying duty cycle, varying dead time wave that's going from, so you can almost see it. If I pause it here, like pause it, you can see this part is part of the sine wave where we are on the upward climb towards the top of the sine wave. And then when we're down here, we've got, try and pause it on a bit that's like negative. Here we go, we've got more negative now. So this is part of the sine wave that's towards the negative. So if we now probe the input of the inductor, so this is actually what's on the speaker terminals if the inductor wasn't there. All the inductor does, look, watch this. If I zoom out, so we're zoomed in real close. We're up at like 100 and something kilohertz on the scope. If I now zoom out on the time divide to where the sine wave actually will show up on the screen. Here we go. Look, turn the gain up. Now it's really kicking out some sine wave. There you go. Short pulse, high pulse, short pulse, high pulse. So if I now probe before the inductor, we have the same thing. And if I zoom out, the sine wave is actually here. This is the sine wave. So this is before the inductor. And now if I move my probe to after the inductor, look what we have. A sine wave. Before the inductor, sine wave, but just with the switching frequency on it. After the inductor, we have the sine wave. So yeah, it's pretty cool the way that it works. And in terms of people saying that Class D doesn't sound as nice because it's like a lower quality version of the sine wave, well, that's kind of true, because if we look back at how the sine wave is captured and turned into digital, well, basically it's taking little snapshots. So this little curve, let's try and get a fresh version of this image. This this part of the sine wave here, okay, all that this is doing, I need to flip that over again, rotate, flip vertical, and then I think that was right, isn't it? Yeah, shift it a little bit. So this part of the sine wave that it's taken a little snapshot of, this just becomes a 1. It just becomes a positive. But let's say, for instance, that instead of just it being a smooth sine wave like that, we've got some high frequency on there. Maybe this is like a full range signal. So let's say that instead of that, let's get the eraser. Let's rub this out. Let's say that there's actually a dip in this part of the audio signal now. And I'm going to match the color of this blue. I'm going to draw in a dip. So let's say that actually that's what the audio signal does, okay, due to, I don't know, a hi-hat or something, okay. So this bit of audio signal that's doing that, the PWM is not picking that up. The conversion to PWM isn't picking that up because it's taking an average of this, and it's not actually following, it's not actually taking samples of this little curvature in the sine wave here. It's not taking samples of each of these bits. It's just averaging the whole thing. And this is what bit rate is. So that's why with Class D amplifiers that are full range, you'll have a much higher frequency triangle wave on top of the sine wave. So I can't definitely not draw a triangle wave, but it will sample far more times. So the more times that you sample with a triangle wave, like this, much faster triangle wave, you get much more samples of that little dip in the sine wave that you can convert into many more pulses, which gives you a much higher resolution version of the sine wave in digital form. So with bass amplifiers, you'll find that generally the sampling frequency is around about 125 kilohertz, which sounds like a high frequency, but in reality, when you look at the way it's sampling, it's not that high. Most car audio full range amplifiers will sample at around about 300 kilohertz. Some amplifiers that are designed to be like Class AB amplifiers without any sampling, any DAC, like the tripath amplifiers, for example, they have a varying sample rate depending on the frequencies that you give them, and I think the average sampling rate is about 800 kilohertz. So the output MOSFETs in a tripath amp are switching at 800 kilohertz, which is very, very, very fast. Okay, let's have a look at some live chat, because I'm sure I've missed a bunch of stuff in here, so sorry guys while I've been nattering on about this. Okay, let's have a look. Any Rudolph the Red-Nosed Reindeer sweaters? No, I don't. I have a Father Christmas sweater, but not a Rudolph the Reindeer sweater. I have a JL/500/1. Has no output. There is no protection light, no smell, nothing. So the JL audio amplifiers, the Slash series, are difficult in the way that even if the amplifier is completely blown, power supply section is blown, output section is blown, they'll still give you a green light, and it will seem like the amplifier is turning on fine, but it's not. Probably not. So what I would do is I would remove all of the clamps that clamp the MOSFETs to the case and just check that none of the power supply MOSFETs are burned, because if the power supply section is not working, it will still give you a green light, but obviously you'll get no output. That's the first thing to check. Come back at me if the amplifier seems fine from the FETs. Oh, hey, check this out. Noobified newbie, your JL probably has a burnt power MOSFET. That's pretty much bang on. It could be right. Yeah, that's pretty much what I just said. Sam, I caught you live. How's it going, Kian? Kian? Oh, shit, I can never say your name right. I'm so sorry. I'm having a really I'm having a really hard time. Oh, what's this? Oh, purified lattice amp modulates have 850 kHz switching frequency. Yeah, that's the same as the tripath amplifiers, like the Phoenix Gold Tantrum 1200.1. That samples at over 850 kHz, especially if you feed it with a high frequency signal. Yeah, mad, crazy thing, crazy. There was something else as well earlier that I did that was 800 kHz. Oh, what was it now? Oh, there was something else I did. Oh, I can't freaking remember what it is. I might even still have it here. It might be an Alpine. It might be an Alpine that has 850 kHz. That's a freaking bass amp. That's crazy. Kian, thank you very much for the 5, buddy. Glad to see. Big man, took a while, but it's worth it. Thank you very much for the 5, dude. Massively appreciate that. I'm so sorry I didn't change the camera. My bad, my bad. I didn't have the chat tickering on the side of the screen. I should have the chat on the side of the screen at all times. I understood it better on the blank screen. Fair enough. So, do you get higher quality amps that have a higher pulse frequency? Yes, absolutely, Martin, you do. Yeah, the higher quality, so you get the so these bass amplifiers, like I say, that are just designed to play lower frequencies. You don't need that high sampling of the audio sine wave because it's low frequency stuff. But yeah, as you get into the higher frequency stuff, the higher the sampling frequency, the closer to class AB operation and sound you'll get. You do still have to deal with, obviously, the additional noises that come with Class D operations. So you essentially, when you plug a speaker in, that speaker, you're listening to a really high frequency noise that... So basically, if you've ever hooked up a Class D amplifier to a tweeter, especially a bullet tweeter, you might notice that when the amp's idling, you get... You get that with some Class AB amplifiers as well, if they're poorly designed, especially if they have a switching power supply section, because that noise gets into the audio section. But a really well designed Class AB amplifier generally won't have any hissing, and that is a low noise floor. But with a Class D amplifier, you also get hissing because the Class D section is switching, and there's like big freaking spikes going on everywhere, so it's difficult to get rid of that completely. A few of you guys had some buffering issues. I've got 0 dropped frames here, so that must be your end. So in simple terms, the only thing between the FET and the output of an amp is just an inductor. Yeah, pretty much. If you measure, you can do it with a multimeter. Let's take our multimeter, okay, and let's measure the continuity between the speaker terminal here, the positive speaker terminal, which is here, and one of the low side MOSFETs. We have a direct short. So yeah, the speaker is connected directly to that massive square wave that we see, but it's through an inductor. An inductor has a low resistance, but if a high frequency is passing through it, it presents a high frequency signal, high frequency wave with a high resistance. Because the way an inductor works, the high frequency, it can't get through it in time before it's kind of back there. It's a bit weird the way it works. I won't go into that right now. But yes, the speaker terminal is connected directly to the low side MOSFET drain, and so all you have is an inductor in the way to get rid of that big square wave that you see on there and leave you only with the sine wave that's generated by the varying dead time or duty cycle of the pulses. Yeah, it's just a low pass filter, exactly. Yeah, it's just a low pass filter. And there are some arguments that say, and there's some amplifier brands that have actually done this. What is a voice coil? What is a subwoofer voice coil? A subwoofer voice coil is an inductor. It's just a coil of wire. So a subwoofer's voice coil is its own low pass filter. And so with some subwoofers and some really shitty amplifiers, Class D amplifiers, they don't run an inductor in between the FET and the woofer, and they rely on the inductance of the subwoofer coil to filter out the 125 kilohertz wave, which it does. The downside of that is that obviously by filtering something, like that energy has got to go somewhere. So the output inductor on the amplifier, it gets warm. It doesn't get really hot, it just kind of warms up, because at the end of the day it is filtering this big wave from being part of the load, and the subwoofer coil will do the same. So if your subwoofer coil is acting as your low pass filter for the Class C switch wave, it will warm up a little bit anyway, just sitting idle, which obviously is not ideal because that slightly changes the parameters of the woofer. So most amplifiers, almost every amplifier, bar like a couple of stupid competition amplifiers that don't care about that, have an inductor in series with the Class D output section. Yo! Is that how you say your name? Simon. I imagine that's probably how you say it. I really like your videos and content on general, so grab some Polish coins. Good to see some valuable content. Oh, thank you very much for the 25 I was wondering what you were talking about there, and I was like, Polish coins? Where do I get those from? But I just realised you sent me some Polish coins. Thank you very much, sir. Massively appreciated. I'm glad that you're enjoying the content. Yeah, it's really cool that you guys enjoy it enough that you're willing to throw some Polish coins my way. Yeah, Chris is right. There are more components in the filtration section other than the inductor. The inductor isn't so good at removing large spikes in the wave. So you have in this amplifier, for example, this Pioneer amplifier has a really good output filter section. Let's take a quick look at this. So obviously the low side MOSFET is here. I think, is this capacitor part of it? Hang on, let me just do a resistance check here. I can't remember if this capacitor is to do with it or not. No, that's for something else. That is, what's that connected to? Oh no, that's part of the low side gate. Okay, ignore that one. So this one, the filter circuit consists of, this is the main inductor, which is filtering the majority of the PWM switching wave. Then we have a couple of massive large film capacitors, and these get rid of the larger, much sharper spikes that do make their way through the inductor. And these spikes actually you get more of these larger kind of spikes when you clip the amplifier. If you're into clipping, then you get a lot more RF noise come through the output section. And in some amplifiers that are poorly designed, if you clip the amplifier all day long, these capacitors will fail. They will get too hot and they will explode. A classic example of that is these new full bridge amplifiers coming from Korea, the Zenon factory. Those Vibe or Edge or DS18 full bridge amplifiers that are like 7K for what do you got? They got a 7K version and a 10K version and a 4K version. The output filter caps are not high enough voltage, and when you clip the amplifier excessively, they really fail badly and they can kill your whole output section. So considering this is such a small amplifier, this is like 1200 watt RMS, we have a really good filtration section. We have initial inductor, a couple of really massive filter capacitors for the spikes. We then have a secondary inductor. Now this is going to be a much lower inductance than the first one, just to clean up any of the remaining stuff coming out of the audio section. As you can see, that's also in, that also has continuity to the speaker terminal. So the speaker terminal, we got this inductor goes through this one, out of that one, into this one, out of that one to the MOSFET, and these capacitors will be on the positive, and the other side will be on the negative speaker terminal to ground any of the spikes through the capacitor. And there's even another capacitor here. So these are film capacitors. Now film capacitors are very tolerant. Well, for example, for a start, they're bipolar, and you can get film capacitors that are very, very high voltage, but they tend to have a lower capacitance. But you've got an aluminium capacitor here, which is also bipolar, a non-polarized capacitor, which will have a higher capacitance than these two. So what they're doing here, what Pioneer are doing, is they're using the benefits of different technologies of capacitor, and they're combining the benefits of these different capacitors to give you the best of both worlds, by having these film ones and this aluminium capacitor here as well. And you've also got this tiny little film capacitor down here as well, which is part of the filter section. So yeah, they're basically combining the benefits of all of these different types of capacitors to give you a really clean output. How does the inductor work? That's a different video. I tell you what, I'll tell you who could tell you about inductors, and that's my man Anthony Volkman from the States. He's been actually helping me out with a bit of information about the in-depth working of transformers, and it is absolutely wonderful information. The video that I've got coming out about the audio pipe upgrades, where I'm upgrading the transformer, I actually do a video call with Anthony, and he explains in depth how transformers work, and that also leads on to how inductors work, because inductors kind of the similar thing, sort of. You can apply the same logic in some ways to inductors. So yeah, wait for that video and you'll learn a little bit about inductors. Evening, Sam. 2 eggs on toast, a cuppa, a bear vid. Oh, nice. That sounds like a great evening, Rob. I'm jealous. Had no idea car amps were using such high frequencies. Yeah, 125 kilohertz is not that high for a Class D switching frequency. It's pretty low. But it's a subwoofer amplifier, so it's like whatever. Doesn't matter. Hey bro, just a thought for you. If you happen to have an amplifier sitting around, let all the people fix it and then give you directions. That's actually a really freaking cool idea. We should definitely do that. Do I have an amplifier that fits that bill? It should be a really generic one, that you will be able to use some of the tips that you maybe have picked up over watching my videos over time. You know what? I could perhaps do this one. So this is an amplifier board that I've got that doesn't have a heatsink. This is just a spare board that I've got. So what I could, this is already pretty badly blown anyway. But what I could do is I could actually like purposefully kill a few components on here that regularly go down. I could purposefully sabotage this amplifier a bit more than it already is. Put it on the bench and then say, right guys, what are we doing? We're fixing this amplifier. Tell me what to do. And then see if live chat can fix an amplifier just using my hands. That would be a sick idea for a video. Who wants to see that? I like that idea. Because, I mean, this is a pretty generic circuit. This is the same as the base phase DB1.3 that we worked on the other night. Yeah, this is using the optocoupled. This is using the optocouplers on the outputs that protects this very sensitive output drive circuit from getting hit when the MOSFETs fail. So that's one of the things I like about these circuits. T-line, next subject. By the way, did you ever finish the T-line doors? Yes, I did finish the T-line doors. Who wants to see some photographs of my transmission line door cards on my Proton in my SQ build? Who wants to see that jazz? Let me just log into my Google Photos real quick and I'll show you some of those pictures. Two-step verification. Very annoying stuff, but I always have my phone on me, so that's fine. Okay, let's go to albums. Albums, Proton. There we go. Let's make sure everything's cool in here. Yep. Yeah, so this is the album that I have on my Google Photos for the Proton. So as you can see here, you can see some photos of the doors getting built by my man Henry at Harwood Acoustics. Guys are absolute genius. So yeah, the transmission line enclosure, which is a 53 hertz T-line, that's kind of in place on the door, and you can see there we've got some resin or some fiberglass and just kind of tacking it in place there. And then there was some expanding foam to help to mold the shape of the edge of the door card there. And then this is the beauty plate, the cover plate to make part of the armrest, holding that down. And this is after Henry had molded part of the shape at the back. That's an old photo of the Proton. This is a photo of the Proton with the new wheels. It looks pretty snazzy, hey? It looks quite nice with the new wheels on. And so this is a photo of 99% completed. The only thing that's missing is a little DD logo plaque in under the door handle. And also this handle, we're going to put some metal plate in there. But yeah, so the T-line obviously consists of the speaker there, goes back down the door card, fires down and fires into the footwell. And let me tell you, the mid-bass response from this system is absolutely phenomenal. I've never heard something like this in a vehicle. The thing with car audio setups is you tend to lack that you tend to lack the impact of that frequency band between like 70 hertz and 200 hertz, just because door speakers, they're playing into infinite baffle. They don't have the ability to really give you that full presence at those kind of mid-bassy frequencies with the speakers up front. But having these T-lines in dedicated enclosures on the doors right next to you is unbelievable. The bass travels through your chest, it vibrates the chair. It's really, really awesome. It's crazy. You can see here with the AW3s from Digital Designs on the pillars. That's all time aligned. And these speakers are AW 6.5s from Digital Designs. They're not made anymore. But they are on their own Genesis dual mono amplifier. So they are on their own amplifier. And I think they're on about, what's the dual mono bridged? I think they're on like 240 watts RMS, which is way too much, obviously. It's just headroom. But I have the amplifiers there, so I might as well use it. Yeah, that's a panoramic view of the front stage. Before that was with the 9855R head unit. The processor wasn't in at this point when I took this photo. Another picture with the new wheels on. Looks quite cool. Would a noise gate work for Class D? I'm not sure what you mean by that, sorry buddy. How does the output section turn the PWM back into a sine wave? With the inductor, that's literally what it is. On the output section, on the MOSFETs, there is obviously the PWM that's changing in dead time, and the change in dead time will result in a varying average DC voltage based on the varying dead time. And all the inductor does is it just gets rid of the switching frequency and leaves you with the average DC voltage of that point in where the dead time is. So the inductor, in fact, the inductor converts it from the PWM to just a pure sine wave. Which brand has a very good Class D SQ amp from mids and highs? I wish I could remember which one it was. I worked on an amplifier not too long ago. Oh shit, I think it might have even been the Stetson. Hey, check this out. Let's have a quick look at this Stetson amplifier. It was a Stetson. Guys, what do I tell you about Brazilian amplifiers being fucking awesome? Check this out, right? This, I think it's this. Here we go. So, now, I'm not the biggest fan of Stetson. Their stuff's okay, some of their stuff's alright, but I'm not the biggest fan of Stetson. But this here is the Stetson EX 1200 EQ. And this has the end plate put on accidentally over the top of the top plate, which I need to correct. Was that me? I don't think I ever... No, this amplifier was fine. I didn't take this one apart. So, we need to sort that out. But anyway, this is the export line, and this is apparently digital 1200 watts RMS at 1 ohm. And now this is a full range Class D mono amplifier. So in order for it to be full range, it needs to have a high enough like audio wave sampling frequency to sound half decent at playing the higher frequencies. Now what really surprised me about this amplifier, so most full range Class D amplifiers for car audio sample the sine wave at around about 350 kilohertz, and I think the highest that I generally see is around about the 500 kilohertz mark. But I think from memory this one was like 800 and something. Let me just open it up and I'm going to probe it just to remind myself, just to have a quick look and see. So let's have a quick look inside. What do we have? Yep, I think this is the one. Okay, let's plug it in and turn it on and see what the switching frequency is. See what the sampling frequency is. I'm pretty sure this was the one that was really freaking high. So we're going to want to probe the output MOSFET, which is over here. Yeah, it is this one as well. Freaking hell. Right, look at the scope screen here. Right, so we need to zoom right in on this switching wave. So look at this freaking switching frequency, 887 kilohertz. This is a Stetson. This is a Brazilian piece of junk amplifier. But it's not though, is it? Because look at the frequency of that. That is a really high audio switching frequency, audio sampling frequency for a car amplifier. Now, I imagine that there are many home audio amplifiers or PA amplifiers that are sampling the sine wave well into the thousands of kilohertz range. Wait, what would that be? No, that would be, that would be a million. Hang on a minute. 800 kilo. Yeah, that would be a million hertz, right? Yeah, a millihertz. What's that called? What's a million hertz called? But yeah, this little thing, freaking awesome. I don't think it's got the best filtration circuit though, as you can clearly see. I have this tiny little inductor, and then this single filter capacitor. So let's see, what do we have on the... Actually, you know what? That's not too bad. That's not even that bad. Okay, it's not the best. So we've got like this, like when we go down, we've got like 300 millivolts worth of noise, which, yeah, you know, it's not great, but it's not the worst thing in the world, especially if you're in a car. You know, cars have road noise and all sorts of stuff like that, so you're not going to notice that really. But the cool thing about this is because the switching frequency is so high, you might think that this looks like a really nasty shape square wave. And yeah, it is not the best looking square wave, and that's because the switching frequency is so fast. So usually, okay, let's zoom right out. Usually you're used to seeing square waves like this. Nice, clean square waves with no like ringing or anything like that. But the thing is, if we actually zoom right in, you can see here that it actually does look wobbly on the part where the FET turns on, and also on the part where the FET turns off. You can see there you have all this kind of wobble and noise and stuff. So the only reason that this looks so clean is because it is a lower frequency. So you're just seeing it turned on for a long time here. Whereas if we don't change the scope settings, look, this is the frequency of the power supply section at 25 kilohertz. If we don't change the scope settings and we probe the output section, look how fast that is by comparison. Power supply, output. So we are zooming in considerably here, like way down to 200 nanoseconds to see this 880 whatever it is hertz wave. And yeah, so it does wobble around a little bit because it's just switching on and off so fast. You're just looking at the ringing. But I was well impressed with that. I thought that was awesome. Like, the Stetson didn't need to do that. Like, the people that are going to use this amplifier are not going to give a shit whether they're not going to even be able to hear the difference through their god-awful pro audio or whatever, or subwoofer. Like, a subwoofer doesn't care whether it's 800 kilohertz or 125 kilohertz or whatever. Like, Stetson didn't need to do that, but they did. Fair play. You know, kudos. But in answer to that question, it does vary. I also worked on this. Now this is a B2 audio 6-channel, and this is all Class D. So this is 6 channels of Class D, and channels 1 to 4 are using they're much lower. They're lower output power to channels 5 and 6. Channels 5 and 6 are dedicated for like subwoofer use pretty much. But channels 1 to 4 are designed for full range audio. Now let's take a look. Shall we see what the sample frequency of this is? Because this is actually designed for full range. Whereas this Stetson here, yeah, it's a full range amplifier, but it's a mono. So most people are going to use this on a sub, and they're not really going to get the benefits of that higher sampling rate. So shall we see then? What do we reckon? Do we think the B2 full range 6-channel amplifier is going to have a higher sampling rate than the Stetson mono? What do we reckon? What's going to have the higher sampling rate? I've got a feeling it's going to be the Stetson, but we can have a look. We can see. Would you like to see that? So this means the transformers in a Class D amp have a center tap like Class AB. Yeah. Class AB and Class D amplifiers don't differ in the way that they generate positive and negative rail voltages. There are some Class D amplifiers that only generate positive rail voltage and they don't generate a negative rail voltage, which are different. The Class D thing still works the same, but the way that it works with only being a positive rail voltage is a bit different. I won't go into that now. But yeah, it's just the output section that's different between Class AB and Class D. The power supply, the rails, everything is exactly the same. How in the world is it possible that the smallest amplifiers can deliver so many watts? And is it good watts? Badass Bill's Stereo, yes, the reason that you are seeing such tiny amplifiers making so much power is just because of progression in technology. Progression in MOSFET technology. So you're used to seeing a 5K amplifier be like this big, and that's because those circuit designs are based on really old circuit designs that were generated and built around the time when you needed a large number of MOSFETs in parallel to create a certain power. However, these days we have advanced so far in MOSFET technology that we have like single MOSFETs that are able to, to dump over 200 amps in a single MOSFET. So we now have MOSFETs that are much higher power per FET. So with a modern amplifier, you need much less components for the same power that you used to need in an older amplifier because they're designed with modern MOSFET technology in mind. Also, full bridge amplifiers, the way that full bridge works in driving the positive and negative speaker terminal at the same time means that the rail voltages inside the amplifiers they only need to be half of what they are in a full bridge amplifier. If you think about it, okay, with a half bridge amplifier, a half bridge amplifier only drives the positive speaker terminal. The negative speaker terminal is just ground. And you've got the positive speaker terminal doing this. So if you want to create a sine wave that goes up to 80 volts and down to 80 volts, then you need to have plus minus 80 volts rails. Okay? That's what you need. 80 volts positive rail, 80 volts negative rail, and the sine wave goes up to 80 volts and down to 80 volts. But in a full bridge amplifier, okay, you only need half of that voltage on each terminal because it's push-pull. So with a full bridge amplifier, on the positive terminal, you'll have a sine wave that goes up to 40 volts and down to 40 volts. And on the negative terminal, you have a sine wave that goes up to 40 volts and down to 40 volts in opposite phase. And the resulting difference between the two sine waves is 80 volts between those two plus minus 40 volts of push-pull. So as a result, with a full bridge amplifier, instead of needing plus minus 80 volt rails to give you an 80 volt sine wave, you now only need plus minus 40 volts rails to give you an 80 volt sine wave with the two push-pull. So by lowering the internal rail voltages, you also reduce the number of components you need inside the amplifier because higher voltage components have lower current handling usually. Like it's a trade-off. If you want high voltage, you have low current parts. If you want high current parts, you have low voltage parts. So by going for lower voltage rails, that means you can use higher current parts, which means you need less of them. That's why you're able to get these tar amps and Stetson amplifiers able to produce like 5,000 watts RMS from an amplifier this big, because it's full bridge, half the rail voltage, and modern MOSFET technology. That's all it is. Oh man, there's a whole bunch of comments. I'm just going to quickly read through some of this live chat because I've been slacking on the live chat a little bit. Pioneer, that Pioneer amp has a very bad efficiency for Class D. It has bad. It has it's you know what? It's not so bad. It's not that bad. Down at 1 ohms, it's not great because the trace thickness isn't the best. But you know, up above 1 ohms, it's respectable. It's like around about the high 70s, or it might even be about the mid 80s. Like sort of like 1.8, 2.2 ohms, which is where you'll be rising to with a subwoofer anyway. If a small amount of clipping is louder in the SPL lanes, what are your thoughts on intentionally clipping the tops and bottoms off the sine waves with a software editor on a career amp? No, doesn't work like that. Because when you clip your signal, okay, then the amplifier will just flatten it back out. Oh, this is a great opportunity to show you that clipped input signal doesn't really matter for subwoofer application. I'll show you that in a minute. Let me know again if you want to see that. What I'm going to do, I'm going to feed an amplifier with a fucking square wave. I'm going to feed an amplifier with a square wave on the RCAs, and I'll show you that doesn't mean that there's a square wave on the output. The low pass filter in the preamp section filters out the squariness of the wave, and you just get a kind of slightly off-shaped sine wave. You don't get a square wave come out the amplifier. If you feed the amplifier with a square wave with clipped signal, it smooths it back out on the output. It doesn't give you a clipped signal on the output. Pioneer makes great head units. Yes, it does. Are you a DJ too? Yes, I did used to DJ. I used to DJ weddings and all kinds of venues and work Christmas parties in big posh hotels up London. Yeah, I used to do all kinds of DJing. Really good fun. Really stressful. Really painful on the back. I hated lugging around the big speakers and shit. Sam, I was talking about car amps using over 800 kilohertz. Yeah, 120 is kind of meh. I can't remember what you were saying yes to, but I'm pretty sure I did it anyway. Let's fix another bass face. Oh yeah, I'll show you the bass face. I'll try and show you the triangle wave on the audio wave with the bass face in a moment as well. So there's two things I'm going to do for the rest of the stream. Show you the bass face, show you the triangle wave with the sine wave overlay, and also show you a square wave going into the RCAs of a bass amp and how it comes out on the output. T-lines indoors, that must have been a lot of work. It was a lot of work. It was about 2 years on and off. Yeah, the problem is with these cars, there are no parts, like there's no kits or anything. So if I want to wide body it, everything's got to be absolute custom made, like from the ground up, which is very expensive. What was the cost for the door panels? I'm not sure if I want to say it was a lot of money. Thanks for the love on the door cards, by the way. Yeah, they're pretty awesome. I've watched several of your videos. You're the smartest and best teacher on YouTube. Man, that's big words. Thank you very much for that. I'm sure that there are better, but thank you. Want to give you respect and tell you thanks. Great work, man. Ken, thanks you very much. I really appreciate that. I love reading stuff like that. Man, that's awesome. Thank you very much for that comment. I'm from Suriname. Nice. Good to see you here, bud. Mr. Worldwide. Love the Christmas sweater. Yeah, it's a good one. Tiny little amp. I saw them, and no, they're not a clone tar amps. They're not a clone tar amps. They're just a Class D amplifier. Like, there's only so many ways you can build a Class D car amplifier. If you want to say that Stetson is a clone of a tar amp, then you're also saying that Ground Zero is a clone of DC Audio, is a clone of Sundown, is a clone of Digital Designs, is a clone of SPL Dynamics, is a clone of B2 Audio. They're all the same designs. They just vary the quality of the components and the thickness of the traces and the number of MOSFETs, number of capacitors, rail voltage level, etc. The architecture of these circuits is like, if you're building a car audio Class D amplifier, you can choose from like one of a handful of circuit designs. You can choose IRS 21844S drive circuit, you can choose a 2010S full bridge, or you can do a half bridge with the 2010 or 2113. You can choose a 2092, which is pretty cool because you haven't then got to design a PWM conversion circuit from the sine wave. You can choose to do it discreetly with like individual transistors, which is really fucking old school and janky. You can choose to do it with a 74HC O2, for example, and you can then use optocouplers to prevent the output section from spiking the PWM generation circuit when it blows. There's only a certain number of ways you can build a Class D amplifier for car audio use, like cheaply, you know, without being stupidly expensive. So they are all going to look kind of, you know, they're going to have similarities between them. But it's in the finer details that dictates whether an amplifier is reliable or not, or whether it makes rated power or not, or whether it sounds clean or not. It's not generally the circuit architecture can be the same between two amps, but one can be really shit and the other can be like really decent. It just depends on how it's been pieced together and the components that are used and the fine tweaks that have been done. Oh, megahertz. Yes, megahertz. Yeah, okay. 1,000,000 hertz is megahertz. Thank you for that. It's kilohertz. They probably use a higher frequencies to get away with a smaller inductor. That's a freaking clever comment, man. That's very true. That is very possible. Obviously, with a higher frequency, you don't need such a large inductor to filter out that frequency because it's a higher frequency. My man, 13BTRX3 probably hit the nail on the head there with why the Stetson is using such a high frequency. Yeah, fucking cost saving. If the MOSFETs can handle the high frequency switching, why not turn it up a little bit and use because the inductors are probably quite expensive. You know, you got a lot of copper winding on there and you got the core as well. In terms of actual cost of parts making an amplifier, the inductor is probably a reasonably expensive part of it. So if you can shrink the size of the inductor without really changing too much else or costing too much else, then that's probably a good reason why. On EXO's channel, there was a guy who changed his RF 2500 amps for Stetson. These amps went into protection really quick. Any reason for this? Without more information, I wouldn't know. Are they going into protection because of heat or low voltage or low impedance? Or there'll be a reason they're going into protection. Just need to know why. It's also possible, like if he swapped out Rockford Fosgate 2500 amps for Stetson, I imagine that the Stetson amplifiers that he swapped them with were considerably more power. Remember, Brazilian amplifiers are rated at 12 volts. So if you've got a Rockford Fosgate amplifier that rated at 2500 watts at 14 volts, if you swap that out for a Stetson 3K, well actually you're not. You're swapping it out for a Stetson 4.5K. So you've just almost doubled your power, therefore also doubled your power supply requirements. So I imagine it was going into protection due to low voltage just because he's got way more power than he realizes. Yeah, guys, guess how much I spent on the door cards. I'd love to see what your guesses are. So, okay, no, it wasn't just the door cards. So how much did I spend on the door cards and the A-pillars? So it was the door cards, the builds, the vinyl, and the A-pillars and the vinyl of the A-pillars. And also some wiring and stuff like that. I have a question, Bearvids. Oh, shit. I lost it. If subs aren't fussy eaters, what makes a sub-amp an SQ sub-amp? Is it a class AB better? Honestly, it kind of makes me laugh a little bit inside when people go on about the differences in quality between subwoofer amplifiers and an SQ subwoofer amplifier. In the most part, okay, there will be some exceptions. If you've got a really freaking awesome, expensive subwoofer in a sealed box, then you will maybe be able to tell the difference between a high quality Class AB amplifier running at low frequencies and a Class D amplifier running at low frequencies. But in all honesty, because subwoofers, for a start, you're playing low frequencies. So the bit rate or the sampling rate of the DAC, the digital to analog conversion in the Class D circuit, doesn't matter so much because it's really low frequencies, it doesn't really matter. Secondly, the subwoofer, like I said, is its own inductor and they are generally, they don't react to sharp changes in frequency, like sharp bursts and stuff like that. Subwoofers are slow and they're designed to play low frequencies, so you don't get any noise. You don't get any noise floor, hissing, anything like that through them either. And also that's why it's very difficult to detect clipping with your ears sometimes with a subwoofer, because the subwoofer doesn't reproduce the sharp edges of the sine wave when it clips. It just kind of carries on, it overshoots. So where your sine wave might square off at the top, your subwoofer just carries on and just completes the part of the sine wave that's missing. So to your ear, the clipping, you don't really hear it so much. So yeah, subwoofers aren't really fussy eaters, and I think that a lot of the thing, if you're installing a high quality Class AB sub amp, then the preamplifier will also be high quality, and that's important. You're probably just hearing the differences between the preamplifier quality and the sharpness of the low pass filter roll off and things like that. One of the reasons that people say that Brazilian amplifiers don't sound so nice on their subs is because the Brazilian amplifiers have quite poorly designed preamplifier circuits and they're full range, which means that they let through, even with the low pass filter all the way down, they let through way more higher frequency stuff than the full bridge amplifiers that are not full range. And some people, even with the low pass filter turned way down, have claimed that they can hear some vocals coming through their subs from their Brazilian amplifiers. That's just a poorly designed preamp. The actual amplifier section of those full bridge Brazilian amplifiers is absolutely fine. If you put a Brazilian amplifier output section onto a Korean half bridge preamplifier section, it would sound fantastic and it wouldn't sound like a Brazilian. So that's why a lot of full bridge amplifiers go under the radar. People don't realize they're full bridge. For example, Orion HCCA 2500D, that's a full bridge. JBL GTO 14001, that's a full bridge. Hyphonics BXI 1600D, that's a full bridge. Vibe Monobox 4, that's a full bridge. So many amplifiers are full bridge that you don't realize, or that are based on modern Alpine MRP 2000D, absolutely brilliant amplifier. Open it up, it's a Brazilian inside. I mean, it's not made in Brazil, but it is the same circuit as what the Brazilians are using now. But it has a proper preamp circuit, it's a well-built amplifier, and everyone raves about it because it's awesome. It's a good thing. But it is the same as a Brazilian amplifier. Inside, the amplifier circuit is the same. Companies are going to be pumping out amps that do rated power, but are built and sounds horrible. Most people only care if it does good on an amp dyno. Yeah, that's true, but to be honest though, like I said before, subwoofers are not fussy eaters, so if it makes power and the sine wave is like reasonably clean shape, power is the most important thing when it comes to car audio subwoofers. Having headroom in power will sound great, provided the preamp is okay. So I would say the most important factor with a sub amplifier for car audio use is power. Yeah, for sure. Whoever come with what you Pinky Love, man, come on, you know better than that. Who came up with the word MOSFET? I think that's a strange name. MOSFET is an acronym. MOSFET is oh wait, what the fuck does MOSFET stand for? Field Effects Transformer. It's a MO. What does the MO bit stand for? MOSFET acronym. It's an acronym. It stands for something. Hang on, no, the Wikipedia doesn't really help me out here. I want to know what the MOS bit stands for. Here we go. What does MOSFET stand for? Here we go. Here we go. MOSFET stands for Metal Oxide Semiconductor Field Effect Transistor. So someone didn't just come up with the name. It's an acronym for what it actually is. That's why it probably sounds a bit stupid to you. I see new Class D amplifiers with Gallo MOSFETs technology, more efficient than the silicon. Yes, I have seen those as well. Taramps have actually made, I think Taramps have actually made some of those amplifiers with those MOSFETs in. And yeah, they are more efficient. They have a much lower on resistance than the silicon stuff, so it's pretty good. His accent makes you want to learn. What do you mean? What does that mean? Really? Oh wait, I've skipped again. What kind of dog do you have? I have a MOSFET. my dog is a pedigree breed of MOSFET. I raised him from very young. He was a bit snappy when he was a young MOSFET, but now he's older. He's very calm. He's a wise MOSFET dog, and he's my life partner. He's a very friendly MOSFET dog. Show us the Rage 1200.6 switching. Yeah, I'll do that. That's cool. What's up, bro? What's up, Mike Honda? Dude, thank you very much, my man, for the 199, the new old base 40. Appreciate that, man. Wicked stuff. Thank you very much. They didn't blow it up. Nope. No, I literally only just fixed this. This was a nightmare to fix. This amplifier would have been a fantastic live stream, but I was busy at the time and didn't stream it during the day. So, what was your DJ name? I didn't have a DJ name. I was doing weddings and shit, man. When you're a wedding DJ, you don't like DJ Hyper Spin or something like that. You know, I was just Venard. What was I? Venard Events or something like that. I don't know. Can't remember. Venard Events Services or something like that. I have a JL Audio JX 500/1D going into protect mode all the time or only when you turn it up. If it's all the time, then I would check the output MOSFETs and drive circuit. I'm just going to skip through these real quick because I need to catch up with the live chat because I'm way behind. Thanks for explaining the Tyrant clone because I was wondering. No worries. Tyrant Smart 3. Yeah, Tyrant Smart 3 is awesome. Buy this amplifier, Tyrant Smart 3. And also buy the new ones. They're coming out with the Smart 5 and the Smart 8, I think. They're going to be sick. Buy them. What brands are using very good technology? Orion HCCA, yes. Rockford Fosgate, yes. JL Audio, yes. Alpine, yes. B2 Audio, kind of, for some of the amplifiers. I would say door panels about $1,000 a piece. Hey, Pinky Love is pretty much on the money. Yeah, the door cards and the A-pillars cost me about 2Ks for that. Thanks for doing this stream. With your help, we'll be repair specialists. Well, hopefully, that's the thing. The reason that I started doing these live streams was I got pissed off with the fact that the world is a throwaway society, has been for quite a number of years, and people are not willing to give a few minutes here and there to, if they've got something that doesn't work. It's been a thing for a long time now where people are like, fuck it, throw it away, buy a new one, whatever, doesn't care. But the cause and the issue might be so simple, might be something so stupid, cracked solder joint, or like something's come off, or like just, man, we need to repair shit more often. Repairing shit is better for the environment. It's very satisfying. It builds brain activity. It's great problem solving and puzzle solving. Essentially, amplifier repair is just puzzle solving. It's just problem solving, and it's really fucking good for your brain. Keeps you active. It's very, very, very rewarding when you fix something and you're like, sick. I just saved myself a bunch of £100 or something because I fixed this shit rather than buying a new one. And then you learn something more about it. And it is such a good thing to do, man. Fixing shit is awesome. Wait, what? What about Top Gear Strong? Oh, I haven't actually seen that video yet. I need to watch that Big D Wiz video about and see what that's all about. What is so special about B&O Ice Power? Not too sure. Haven't looked at any B&O stuff. Sorry, can't give you any information on that one. 3,000 quid. Okay, it was a bit less than that. Yeah, 2Ks for the doors and the pillars. That's not including equipment. That was just for the builds. Hello from Sundown Audio. Oh, dude! Holy shit, Sundown Audio. Keep up the kick-ass videos. Man, I appreciate that. You know what? That is actually so nice. That is so nice of you guys to come on my stream and say that. Because a couple of years ago, we were obviously doing DD versus Sundown. And I tried to make those videos as bias-free as possible. Obviously, I had an investment in digital designs. And I had a Sundown team and I had a Digital Designs 99, and I tried to, I love Sundown Audio. I wasn't making those videos to try and big up the DDs at all, but the last video that I did, there was a bunch of rushed things with the box, and basically it looked like we were favoring the DD, and I know that Sundown got pissed off, and that's not what I wanted to happen. I wanted to give both these woofers a fair chance against each other to see which one performed the best in average, like across the board. And I know that I pissed off probably a couple of guys from Sundown for releasing that third video. I only had it up for like a day before I took it down, but I know that I probably lost a bunch of credibility because there was some stuff that we rushed with the enclosure and it looked like we were favoring the DD. So to have you here on the stream, bigging me up, thanking me for the videos is a massive thing for me. So thank you very much for jumping on and saying that. That's really, really awesome. Yeah, everyone's, to be fair, I was expecting people to underquote it, but yeah, you're pretty much bang on. That's how much it cost. Yeah, nice one. What do you think of the Stetson EQ 2100 EX? Shit, I have used the 2100. Isn't that only a 10k amp? Isn't it 2100 peak? Hang on a minute. Stetson 2100 EQ. What is that? What it's called? EX. Here we go. EX 2100 EQ. Let's have a quick look. Export line. Oh shit, no, it is 21k at 1 ohm. Fuck. I don't think I've actually worked on one of these before. Right, here we go. The problem that I have with the Stetson export line, the amplifier circuit design is okay. It's nothing special. It's nothing like the Tyrant Smart series. It's not quite up there with the Banda. It's not quite up there with the Sound Digital. It's okay value for money. The problem I have with the Stetson export line is the build quality of the PCB and the heatsink is shockingly bad. Like, do not mount these amps on your sub box. Their vibration damage will snap all of those MOSFET legs. I have seen this. I have repaired multiple Stetson bigger amplifiers from the export line to know this. They are not built very well. I would probably steer somewhere else. If you're looking at that much power, I would probably look at the Banda Viking 15K or something from Sound Digital. Sound Digital has its own problems as well. They're not perfect. Banda has their own problems as well. They're not perfect. You know, it's a bit of a tricky one if you're looking at that much power. If I was gonna buy it though, I would probably buy the Bandas still. They do, you know, Bandas still has some reliability issues, the same as they all do. But at the end of the day, the Bandas are the better built amplifier and the better built circuit, in my opinion. SQ in subs based on the damping factor. Yes. No, yeah, he's right. Bad John Astan. Yeah. So obviously a higher damping factor will bring the cone of the subwoofer to a halt much faster than a lower damping factor, which will help in the subwoofer sounding responsive and quick and, you know, reactive to different changes in bassline. What do you think of the Viking 15K? Pretty awesome. The 10K is a slightly better design amplifier. The 15K is a little bit raw. It's a little bit like stripped down, like a bit dirty, a bit more dirty design. The 10K is more of a daily kind of big amplifier. The 15K is more of a competition kind of amplifier. Still good, but it's a bit more stripped back than the 10K. The 10K has better filtering and stuff like that. What equipment would one need to start working on Class D, and where should they study up? Okay, just really quick, I'm doing a separate video on this, but just a really quick summary of what you need to start working on car amplifiers. You need, very important, a decent quality, adjustable voltage and variable current bench power supply. Something like I have up here. So this is my bench power supply, and I can select anywhere from anywhere from 0 volts all the way up to 16.3 volts, which is perfect for working on car amps. And I can select anywhere from 0 amps all the way up through to 20 amps of current to pass. And it's really important that you get a power supply that's clean, that is a decent quality one, because a lot of these power supplies from China, the output voltage, because these are switching power supplies, although I think this one's actually a linear power supply, but most of the cheap ones are switching power supplies, and they don't filter very good on the DC output. So when you're trying to probe like very, very tiny square waves and audio waves in your amplifier, you're just going to get a bunch of noise on your scope screen because the power supply is dirty. So high quality laboratory or bench power supply with variable voltage, variable current. Try and get one with at least 10 amps. 10 amps is a bit low, like some amplifiers will draw considerable power. 20 amps is a good value that I've got here. That's the first thing you need. Second thing you need you need a soldering iron that is at least 60 watts with a variable temperature, and you need a hot air soldering station. You can get a pretty cheap one. My one here is pretty cheap. It's nothing special. It's a Chinese special AOUA all-in-one soldering hot air station. Not particularly high quality. The soldering tips have their heating element built into the tip, which is expensive when they break, like this one has. They're like £15 every time you need to replace it. And yeah, it's okay, it does the job. If you have money, then get a Hakko soldering station and stuff like that. Get the proper stuff, because you won't have to clean it as much and stuff. But at least 60 watts. If you're doing transformer removal and terminal removal, get at least 80 watts, because that will make your life a lot easier. Another thing you need is a big ass heat gun. You need to preheat the board before you start working on it, because it makes soldering a lot easier. Then, the most important part of all, you need a decent oscilloscope. Try and get an oscilloscope that has some kind of digital functions. So here I have an HP oscilloscope, which is a 54620B. You want to try and get an oscilloscope that gives you a reading of volts RMS, frequency. You can also get ones that show you the period, the duty cycle, the volts peak to peak, the average, etc. Try and get one that gives you some digital readings on the screen there of the things that it's reading. And also, it's really handy to have a scope that is at least 2 channels. This scope is 4 channels. I rarely use channels 3 and 4, but I always use channels 1 and 2. I hook one channel up to the rail voltage as the amplifier is building rail voltage, and I hook a second channel up to the output switching frequency, so I can see when the Class D switching activates. Very, very good thing to have. A scope is essential. You cannot do reliable car audio amplifier repair without an oscilloscope. People ask me all the time, can you tell me how do you repair car audio amps with a multimeter? Easy answer, you can't. Get a scope, then repair your amplifiers. Multimeter. You don't need a fancy multimeter. I use my oscilloscope for all of my voltage readings. All of the readings of voltage that I want to take of the amplifier, I use my oscilloscope. And the reason for that is that because I can see with the oscilloscope whether there is any quick fluctuations or waves on the voltage that I'm reading. Very useful. An oscilloscope is your eyes. An oscilloscope is your eyes into the circuit. You can probe a point on the circuit and you can visibly see on the screen the activity of the electrons on that bit of circuit that you're probing. A multimeter only gives you a very, very basic view of that. It just tells you the voltage. It doesn't tell you the shape, doesn't tell you the wave, doesn't tell you anything about it. An oscilloscope is like looking at the electricity in the amplifier, and it's very essential. So for a multimeter, you only need a really freaking cheap one. Just something that gives you ohms reading, and most importantly, something that gives you a continuity mode. That is the thing that I use all the time. Checking for continuity, finding what component connects to what, finding shorted components. I only really use my multimeter for resistance checking and for continuity mode. Literally, I pretty much only use it for continuity mode. Another thing that you should definitely buy if you're getting into amplifier repair is a transistor tester or an ESR tester. This is pretty cheap. You want to make sure you get a legitimate one. This is the MK328. Is absolutely essential for checking MOSFETs and matching MOSFETs up with each other in terms of VT, RDS. If you're going to buy one of these, make sure that it says EZM, Electronic Studio, on the bottom. If it doesn't, it's probably a fake and it doesn't give you accurate readings. You want to get a legitimate one. These are like 20, 30 pounds, pretty cheap. Definitely worth buying. Next thing you need, well, next thing you probably should get if you can, not the cheapest of things, you should try and get yourself a thermal imaging camera. This has been an absolute godsend for finding components in the amplifier that are faulty. If you've got an amplifier that powers up, doesn't have audio, there's a short circuit somewhere, it's drawing a load of current. If an amplifier is drawing excessive current, that means that something is heating up. And you can't see what's heating up with your eyes until it starts smoking, at which point it's probably too late and the damage has already been occurred. So get yourself a thermal imaging camera, £150. It will pay itself back in repairs in a couple of weeks from finding shorted driver ICs, voltage regulators, resistors that are getting too hot, MOSFETs that are getting too hot. You absolutely need a thermal imaging camera to do amplifier repair reliably and to make sure that your amplifier is 100% perfect before it goes back out to the customer or before you sell it. What else do you need? I'll tell you what you do need. You need a freaking foot pedal, right? Don't laugh. This is one of the most important things when you're working on car audio amplifiers that you should have, because when you're working on car audio amplifiers, to turn the amplifier on, you have to connect the remote wire to the amplifier, which gives 12 volts to the remote to power the amplifier up. Now, if you're plugging the remote wire into the amplifier like every time, if there's a problem with the amplifier, if there is something wrong with the amplifier that you notice on your oscilloscope when it powers up, the output drive wave looks like shit, it's drawing a load of current or something, then you only have a few fractions of a second before irreversible damage happens. The amount of time that it takes you to move your hand, drop your oscilloscope probe, go over here and pull the remote cable out is too long. Having a foot pedal for the remote lets you instantaneously, just instinctively, lift your foot off the pedal if there's a problem. And it also allows you to like pulse the remote, to pulse it. Like if you want to turn the amp on slowly, you just pulse the remote a few times, build a few volts of rail voltage, check the voltages. It frees up your hands to use your oscilloscope and to use your tweezers and stuff like that. It's so good. Get yourself a foot pedal and hook it up in series with a 12 volts line and the remote. That's pretty much it for the basic stuff. Is the Viking 15K better than the Tyrant's 12K? Yes, it is, in my opinion. Daniel Pond, thank you very much for the $5, my man. Massively appreciated. That's awesome. If preamp smooth square wave, what's the best way to intentionally clip a sine wave burp? The only way to intentionally clip is just to clip the amplifier. Like, just go beyond the clean output of the amplifier. When you're talking about subwoofer SPL competitions, you should clip your amplifier. You might think that's weird for me to say, but if you are competing, if you are trying to squeeze every single last 0.1 dB out of your system for competition in the lanes, then your burp, your burp of tone only needs to be half a second long, and for that half a second you want your amplifier to be quite far into clip, because clipping the amplifier does transfer more power to the subwoofer and it will be louder in clip than if it was purely clean. Clipping an amplifier for 0.5 seconds is not dangerous. The danger to amplifiers is excessive power or excessive current draw from the amplifier over time. A short burst of 0.5 seconds of quite heavy clip into your subwoofers is not going to kill your amplifier and it's not going to kill your subwoofers. A tiny burst is fine. What kills electronics and subs and coils is power over time. It's total energy dissipated. If it's only a tiny burst, then the total energy dissipated by that equipment is very low. However, if it's a high amount of power over a long period of time, then the total amount of energy dissipated by that equipment is very big, and that's what causes the problems. Greetings from Germany. Finally got some time to watch the stream again. Could you have a look at over the circuit of a Sinus Live SLA? Maybe. I haven't got one of those. I've never seen one of those. If you want to send me one of these to have a look at, I will gladly have a look at it for you. But I haven't actually looked at one of those before. DJ MOSFET, yes. What are Edge like as an amp make? They're the same as everything else. Edge don't design their own circuits. They go to a factory. They say, oh, I would like one of those, please. Please put this quality of like, I want quality level 4 of this amplifier, and there it gets shipped out. Edge don't design their own amplifiers. Some of the stuff they produce is fine. Some of it is sketchy. You know, it's okay. If you want to take the risk, it's fine. Shit, I'm really I need to catch up with this live chat far faster. Any words about Kenwood KAC? Kenwood stuff is good. I don't know off the top of my head the power ratings of that model, but Kenwood stuff is good. Please tell me your thoughts on the Viking 15K. Done that already. Mo will turn the amp on to protect when I turn the amp on before the head unit. Okay. Is it still in Protect, or is it out of Protect now, or is it dead? I've tried to... he owns that. Yo, buddy, your vids are deadly as fuck. Thank you very much, buddy. Wait, I think that's a compliment. It could also mean that the repairs are so bad that they're like dangerously deadly, which could also be true. Should look into doing or starting an online school for amplifier repair. I don't know of anywhere in the US that does it. Well, that's kind of what my YouTube channel is already, but I know that the videos are kind of scattered around and the information is scattered around in various live streams and stuff, but it kind of is already over there. Do y'all have a kicker brand? Yes, we do have kicker, but we don't really, there's not a lot of it. It's very expensive because it's shipped over from the States, so not really anyone buys it. The only kicker stuff that I repair is like old school kicker. I have repaired a couple of Warhorse amplifiers, actually. I have a separate video about how the Warhorse amplifier works, because it's very strange and it's very shitty. Is the Tyrus 15K strappable? No, it's a full bridge amplifier. Full bridge is not strappable. By the way, my girlfriend and I both really enjoyed your trip to Australia vlog. Oh man, Mary, thank you. I really spent a lot of time and effort editing all of those Bear Vids Down Under videos, and I had a blast out there. Guys, if you haven't watched my Bear Vids Down Under videos, they're sick. I love that. I love doing those videos, man. Go check those shit out. That's so cool. You can buy it in, well, you can't buy this anymore because this was last year from Primark. Sorry, you might be able to buy it off eBay. Hell yeah. Yeah, okay, maybe I could do something like that, but I guess it could be more structured than my videos are. But to be fair, Perry has already done that, but in written form in Perry's amplifier repair guide. I didn't know MOSFET was an abbreviation. Yeah, I do now. Yeah, I just remote started my fireplace. Is it okay to stand your amp on its side beside your box? Will it damage the amp? Yeah, the electrons will fall out. No, I'm joking. Yeah, it's fine. Actually, standing your amplifier up, like loosely, is actually better for it than being screwed to your box, because the vibrations from the box don't transfer into the amplifier when it's just like loosely standing there. So actually having your amplifier loosely standing there in between a few cushions is actually better for it than screwing it to the box in terms of vibration damage. Probably not in terms of heat, but you know. Horn, soft dome, or dome? I like the... Actually, freaking hell, I like ribbon tweeters. Man, freaking hell. What's it? Electrostatic speakers sound fucking awesome. Ribbon tweeters are lovely. Hey Sam, about the Cadence, 18 volts Korean made. How about the Cadence ZRS competition? Let's have a quick look at these real quick. I'll try and do it as quick as I can because I'm trying to get through this chat. Because it is balling. It is balling this evening. Do I have a gut shot? Is that what this is? Oh, this is generic. This is oh, come on, give me the pictures. On this old ass forum. When was this? 2012. Fucking hell. Come on, load the pictures. Load the pictures. It's not going to load the pictures, is it? Okay. Oh, here we go. Yeah, okay, so this Class D amplifiers is the same as everything. It's a DC audio, it's a ground zero, it's a sundown, it's a digital designs, it's an SPL dynamic, it's an atomic, it's a, yeah, it's the same. It's just an IRS 21844S quad output half bridge. You know, these are fine. These are relatively reliable as far as car amps go. They're fine. They're pretty cool. They're not very efficient and they're big compared to the stuff that you can get these days. If one creates a T-line box running at 30 Hz, will a woofer that starts responding at 42 Hz create... what? Yeah, yeah, you can put any speaker in a 30 Hz T-line and it will play 30 Hz, but if the speaker is not well suited to a T-line, it might just sound a bit weird, but it will still sound like 30 Hz, kind of. Thoughts on the sound quality of the full range, full bridge on Brazilian type amps? Yeah, so as I said before, in a car audio environment, they're going to sound fine, but the lower bit rate of car audio Class D amplifiers will leave you lacking in the twinkly top end of the trebles, and also there'll be quite a high noise floor because of the poor filtering on the Class D amplifiers. So I'm not a huge fan. In my Proton, I run Class A on the tweeters and the 3 inches. Class A, not even Class AB. By the way, I feel like you should... Oh shit, it's gone. Where was it? By the way... Why aren't you using your bench power supply to power your RDA? My RDA? Huh? I don't know what my RDA is, sorry. Shoot a video on... I feel like you should do a video on how to bridge 2 servo power supplies together to make one beefy. Just parallel it. They work fine in parallel. There's nothing to it. Just plus to plus, negative to negative. Just parallel them. You don't need to do anything special. Any types of electronics work, you need a scope. It's essential. I agree. Absolutely. An oscilloscope is fucking essential for electronics work. Beverage, are you going to be on Kicker Unmasked? I don't know. I haven't been invited to that. No idea. Off topic, could you possibly explain why Brazilian amps sound different from Korean amps? It's all in the preamp section. The reason Brazilian amps sound differently from Korean amplifiers is just because Brazilian amplifiers have a full range optimized preamp section, and therefore they sound different. If you took a Brazilian amplifier section and you put it in series with a Korean preamp section, then it would sound just as good, although slightly less dynamic power. We'll get onto that. I'm doing a video on that as well in the future. But it will sound kind of the same. The reason that Brazilian amps sound different is because of the preamp section. Okay, I'm just gonna probably scroll through this because I'm sorry, there's so much chat. Man, Mike Honda, dude, thank you for the 20. Thank you very much, dude. Shit. I was saying an online school to get repair techs out in the world for service and repair beyond company service. So we aren't at the mercy of the manufacturer and provide quicker service. Yeah, I do agree. And Jason, thank you for the 20 as well, my buddy. Massively appreciate it. If you've got a question or anything, give me a shout. But I really appreciate the 20. That's massive. Thank you, dude. Massively appreciate it. I could possibly do an online amp repair school. I would have to prepare for a long time, obviously, and work out exactly the structure of it. But yeah, I could maybe do something like that at some point. It might be cool. Guys, here's a little secret for you guys that are watching my stream right now. Here's some information that I won't be giving to anyone else for quite a few months. I have just had an offer accepted on a house. So as some of you may know, my workshop here, I live with my parents. I'm 29 years old, and I have a fantastic relationship with my parents, and we get on super well. My house here is pretty big, and I have very good privacy here, so I've never felt the need to get my own place and be financially worse off, because I love my parents, I get on so well with them, so I'd be financially worse off and I would have less money at the same thing as that, and I would be more lonely, I would miss my parents. So I haven't moved out yet, but now I actually am with somebody and have been with somebody for a couple of years now that I want to live my life with, so I have now had an offer accepted on a house. So there's going to be some fucking cool videos coming of me setting up like a home cinema system, a fucking listening room with some electrostatic speakers, a new workshop. There's going to be a whole bunch of awesome stuff coming, probably towards the end of next year or something like that. So that's a little teaser for you, just into my personal life, because I don't do many videos or live streams about my personal life. It's all just amp repair, electronics, like fucking audio shit. Please tell me your thoughts on the Twisted Sounds 8.5K. It's generic, but it's well built. The Twisted Sounds amps are actually quite well put together. So out of all of those similar half-bridge amplifiers, they are one of the better ones. So yeah, not bad. Vape. I don't vape anymore. Sorry. That was pretty stupid. When will we see videos of the yellow car? I need to do a few things to the yellow car. I need to tidy up the bodywork. I need to finish off the install completely. Then you'll get videos of it. I was meant to do that this year, but because of COVID, I wasn't able to get the car to the places that it needed to go to. I wasn't able to see the people that I was meant to be seeing to get it finished, so that hasn't happened yet. It's coming next year. Do you know something about the sound quality of the Class AB Brazilian amplifiers? Class AB Brazilian amplifiers are MOSFET final. They do convert the sine wave into PWM, so they are not strictly linear amplifiers. So it depends on, I would have to look into it and look into the one that you're asking about. But yeah, Brazilian Class AB amplifiers are Class AB. They do sound nicer than the Class D, but there is still some DAC going on. They're not strictly linear like a normal Class AB is. Sean, thank you very much for the 5, man. Awesome. Just because you, Sam. That's freaking awesome. Thank you, dude. Massively appreciate that. Dude, thank you very much. JL Audio recommends setting up their amp to 50 Hz. Fellow electrical engineer here. Just keep making videos and don't lose the accent. I'm not going to lose it. Well, I don't have an accent. Well, as far as I'm concerned, you know. Actually, I got some voice clips from some guy from Texas earlier on my Bearvidge Facebook page, and like, to me, he had a pretty heavy Texan accent. That's the funny thing about accents, isn't it? Is that when you listen to yourself, you think that you're talking perfectly normally. But obviously, depending on where you are in the world, that could be very strange. So, yeah, accents are weird. Yo, I'm 30. I live with my parents too, sadly. Man, it's not such a sad thing. If you live, like, to be honest, right? The whole thing about the pressure to move out of your parents' house is kind of a bit outdated, okay? Back in the day, the difference between the house prices and the average income of a couple was much closer than it is now. So, honestly, if you don't have a reason to move out, if you don't have somebody that you want to move out and start a life with, why would you put yourself in a situation where you are financially worse off, more lonely, more isolated than if you, provided you have a good relationship with your parents, of course, unless you really desire the independence and everything, or the space, then yeah, for sure, provided you can afford it, because it's fucking expensive these days, especially in the UK to move out, then for sure, move out. But if you are very happy and you get on really well with your parents and you consider them to be your friends and you have enough privacy and you have enough space at your house to do what you want to do, then just wait until the time is right. Wait until the time is right. There's no pressure to move out, man. Congrats on the house. Thank you very much. Thank you very much. This video is awesome. Usually you are just trying to get back to fixing something, but this video you have time to just answer questions. I know that wasn't the initial point, but Q&A is awesome. I'm glad to hear that. That's kind of what this video has turned into. I'm glad that you guys are enjoying it somewhat. It's kind of like firing backwards and forwards between us guys in the chat. It's nice. You know what? Actually, how many people are here right now? Holy fuck, 134 people. Jesus. Okay, well, I was going to say we should start a Discord, but I don't know about like 134 people all chatting at the same time on their microphones might get a bit intense. What would you guys say to a Discord? Should we set up a Discord for the regulars that always are in the live chat on my live streams? You know, somewhere that we can just chat about stuff. You can ask questions. I can respond to you guys during the daytime when I'm not streaming. We can have some kind of voice chats at some time. We can maybe do a Zoom call at some time. I can help you out with amplifier repairs. Maybe I should start a Discord. Hey, that might be a cool idea. Thank you for answering the few questions I had. Good info. No problem, buddy. Thank you very much, Chris. That's really kind of you, man. I'm in the same boat, dude. Just got a house and going to be starting amplifier repair myself. Awesome, man. Definitely jump in there. I'm happy. I'm here to help. Like, shoot me a message on my Bearvidge Facebook page. If you've got any questions with starting amplifier repair, man, hit me up. I'll try and help you out best I can. You have reached the end of the chat. Now get on with the show. Yeah, you're right. I should. I'm almost there. I'm almost at the bottom of the chat. I'm almost there. Yes, you have an accent. Blah, blah, blah. Thank you very much, PA and Carl Hi-Fi, for the 1. That's awesome. Thank you very much, buddy. What do you think about B and C speakers? I have a... Oh, yes, these are sick. Dude, that must be awesome. I would love to hear that. I would love to hear that system. 21 iPower is a sick driver. That must be a fantastic system. If you've got any videos of that, let me know and we'll check out your channel. Texas accent here. Yo, what's up? Oh, wait, I know I can't do a Texan accent. No, I'm not even going to try. This is not going to go well. Not sad. I have a buddy here that lives in his dad and mum basement, but is one of the top 10 Subaru salesmen in New York and drives very exotic cars. Exactly. Right. How many of you guys watch Jimmy Broadbent on YouTube? This is a guy that lives in a shed in his mum's garden and is one of the most successful sim racers on YouTube, and he now owns a whole plethora of exotic cars. Well, he's getting there. He owns an R33, he owns an R35 GTR, he owns a couple of other cars as well. He's doing very well for himself, and he actually has just had an offer accepted himself on a house, but he was just living in his mum's shed in the freaking garden, and he's an awesome guy. Go if you're even vaguely interested in racing of any sort, go watch some Jimmy Broadbent. It's fucking awesome. He's a lovely guy. Yes, thank you, dude, man. Bad John Athan, thank you for the 20. I don't know what 20 BGN is, but Bulgarian something maybe. No, I'm not too sure. Sorry, but that's awesome. Thank you for the 20, my man. But you have channels and rooms in Discord. I think it's better. Yeah, we could do Discord. Discord is an excellent idea. Definitely better if you're not streaming. Yes, yes, yes. Discord. Okay, we're making a Discord. Reminds me of watching Top Gear. I mean, the one with Jeremy Clarkson. Jokes. Is it worth repairing a toroidal transformer on a 400-watt amplifier? Depends on how badly you need to repair it. Like, how badly is it damaged? Yes, like, why not? If it's yours, then why not repair it, man? Absolutely. Fucking, if you can repair it, then repair it. Absolutely. Okay, right, guys, we have reached the bottom of the live chat. So now we are just going to really quickly look at the switching frequency of this B2 6-channel amplifier. Because we want to see, is the switching frequency of the B2 6-channel amplifier, is it higher or lower than the Stetson amplifier? Be so funny if the Stetson amplifier is a higher switching frequency. Wouldn't that be freaking hilarious? But you know what? I don't think I even have to take the back off to look at the switching frequency, because I think the filtration circuit in this is so poor that we can zoom in on the scope and just probe the speaker terminal and have a look at the noise coming off the speaker terminal to tell us what the switching frequency is. So let's just plug our wires in here to the amplifier, and the remote on this one goes around the other side of the amplifier on near where the RCAs are. There we go. Remote in and power supply on, and scope screen on the chat on the live stream, and let's power her up. I'm gonna go straight up with 14.2 volts, 14.4 ish, and I'm gonna give it like 20 amps. Come on, let's get this thing powered up fast. So let's go for channel 1 plus, and let's have a look at what the switching frequency is. Yep, there's a fucking shitload of noise on there. Okay, so the switching frequency, oh no, it's not good news, guys. It's not good news. Oh wait, maybe, hang on, let's have a look. Oh, the scope is having a hard time finding it because it's quite noisy. Oh, I think it's about 300. There we go, that's better. Yeah, okay, it's about 250. Okay, yeah, it's about 250. So 250 kilohertz is the Class D sampling frequency, or the PWM sampling frequency of this B2 audio full range amplifier. And when you compare that to the sampling frequency of this Stetson amplifier right here, that has 880 or 850 or whatever it was, that's quite a bit lower, hey? It's quite a bit lower. What's the I wonder if the sampling frequency is the same for the sub-channel. So channels 5 and 6 are actually the kind of sub-channels. So let's have a quick look at the sub-channel, see what that is. The sub-channel is, yeah, I think it's the same. 200 and something. Yeah, it's about the same. Perhaps a little bit lower. No, it's the same. Yeah, so yeah, actually quite a bit lower than the Stetson. Yeah. Anthony Knorr, thank you very much for the 10. My goal is 180 decibels. If I had you to talk with personally, I could make that goal. I don't know about that. Like, I know a lot about amplifiers, and I know a reasonable amount about audio in general, but when it comes to making 180s, like, generally you need real world experience in doing that. Like, sort of the person to talk to is probably someone like Alan Dante, who's actually done that and is doing 184, 185 dBs. I'm probably not the right person to talk to about literally getting that 180 dBs. I could potentially help you get there, but I don't have the real world experience with dBs that high. Can you explain the difference in switching frequencies? Why is one better than the other? Well, a higher switching frequency means that the amplifier is taking more samples of the sine wave to turn it into digital, or to turn it into pulses. So the higher the switching frequency, the higher bit rate the sine wave coming out the amplifier is, which is good for full range and for tweeters and for high frequencies. Doesn't really matter so much for low frequencies and subs. Yeah, 180 dB is not an easy ask. 180 dB is the kind of thing that requires you to line your vehicle with concrete, and to get 180 dBs, the car is not going to be drivable daily. Like, it's going to be a trailer queen, or you're going to be able to move it around a car park, but it's not really going to be able to be driven properly on the roads. Probably won't get an MOT, probably won't, be legal to drive on the roads. So guys, I was going to show you the bass phase with the triangle waves and how it converts that into pulses, but I pretty much kind of showed you that already in here. It's just going to look the same as this, just in the amplifier. So what would you like to see next? I've probably got about another 20 minutes on the live stream. It's getting pretty late now. I've been streaming for over 2 hours. So if you've got any questions, get them in now, or if you would like to see anything that we talked about earlier that I've forgotten about. Oh, there was one thing that I wanted to show you. Okay, what happens when you feed a subwoofer amplifier with a square wave, and what does it look like on the outputs? Let's do that real quick, because that's pretty interesting stuff. So what happens if your head unit is clipping the subwoofer output? If your head unit is clipping, does that mean that your subwoofer is going to be damaged by the clipping? My answer is no, and let's see why. Let's see why that doesn't matter. So what I'm going to do here is I'm going to take my signal generator. I have a signal generator that is capable of creating sine waves, triangle waves, and square waves. So let's ask it to create a pure square wave. Now, your head unit would never ever give out a pure square wave, even when you are heavily clipping your head unit, it's never going to be a pure square wave like this. But just for experiments purposes, let's give the amplifier a pure square wave. So here we are, I'm probing the RCA right now. Shit. This is a pure square wave at 46 Hertz going into the amplifier. Okay, let's turn the amplitude up a little bit. There we go. So we have a 1.6 volt RMS pure square wave, and we're going to plug that into our amplifier here. Into the inputs. There we go, just to show that. Square wave on here, going in. Square wave, going in. Now, let's see, what does that relate to? What does that turn into on the outputs of a subwoofer amplifier, I wonder? Let's have a look, shall we? So I'm just going to take my probe here and probe the output of this sub amp. Well, would you look at that? A 42 Hertz, actually it's 42 Hertz now, a 42 Hertz square wave on the RCAs. Look at this, I'm probing the RCAs. There's your 42 Hertz square wave. That turns into a 42 Hertz perfect sine wave on the speaker terminals. Square wave on the RCAs, sine wave on the outputs. Does clipping your head unit matter? Yes and no. Clipping your head unit is not good because it reduces the dynamics of your music. It just makes everything sound the same volume. And it's especially not bad for high frequencies. You don't want to clip your head unit when you're listening to your high frequencies. But if your subwoofer output from your head unit is clipped, is it going to damage your sub? No. No, it's not. The amplifier is going to turn it back into a square wave. Into a sine wave. How many people were blown away by that? I want to see you sing the box song. Wait, what's the box song? 13BTRX3. Hey, dude, you have donated enough to get your request fulfilled. So just remind me, what do you mean by the box song? $120 dBs is plenty until you daily drive 140. Then it isn't plenty. I agree. A good amount of bass, I think, for daily driving is about 142-ish dBs. Sounds lovely. Like, it's loud enough to be like, yeah, this is bass. But it's not so loud that you end up damaging you end up ripping door cards, you end up like with vibration, like flex damage in the car. You know, you don't need so many batteries to make 142 dBs. It's just, and it doesn't make your music sound like shit either. 142 dBs of bass is actually a nice little round number to have. Clipped input signal. There we go. Yeah, we did that. Yes, we did that. Let's see, what else did people want to see? Tour of the workshop. Oh, how can I do that? Because all my cameras are like tied to the bench. There's not much going on with the workshop, really. I could give you a tour, perhaps. How can I give you a tour? I've got one of the cameras that's like got a big long wire on it, maybe. Maybe I can do a separate video that's a tour. Would an inrush current limiter do the same thing as your soft turn-on circuit does? No, it wouldn't. Inrush current limiter will not do the exact same thing for many reasons. It's very complicated. I won't go into it now, but it's not the same thing. Knowing I need to clip to do a burp in the lanes for max SPL, what's the best way to clip when I have to stay under 2K clamp? Oh, well, that doesn't matter then. If you have to stay under 2 kilowatt clamped, then clipping doesn't matter. In fact, if you are limited to a certain power rating, don't clip, because you are louder. Like, okay, so let's compare 2 kilowatts clean versus 2 kilowatts clipped. The 2 kilowatts clean will be louder than the 2 kilowatts clipped. So if you're limited to 2 kilowatts clamps, then don't clip. Just try and get to 2 kilowatts cleanly, and then you'll be louder. The only time that you want to clip is if you don't have any limitation on your power clamp rating, then just fucking full send. Straight into clip, and you'll get loud. In your opinion, is a Genesis Profile 2 worthwhile repairing if it's missing the low pass module? The Genesis amplifiers are fantastic. I would say yes, worth repairing. And just use it for full range stuff. Have you ever seen a mono Class D amplifier with uneven outputs? Example, 6 FETs on one side and 7 on the other. Yes! Old Class D amplifiers that use N-channel MOSFETs with P-channel MOSFETs. Like Solid Audio F2500D or the Crown 2K and Orion 2500D. Those amplifiers use N-channel MOSFETs, which are 640N, and P-channel MOSFETs, which are 9640. Now, because they're using N-channel and P-channel MOSFETs, the 9640 P-channel MOSFETs are much lower current than the N-channel MOSFETs. So what you'll find is that in some of these amplifiers, you'll have, on one side of the amplifier, you'll have maybe 6 9640s and 4 640Ns, because the 640Ns are higher current than the 9640s, so you need less of them. So yes, I have seen that. Any amps are switching in the megahertz region? Not that I have personally seen, I don't think. Maybe the tripath amplifiers, because tripath amplifiers vary the switching frequency based on the input signal you give them. So if you have a tripath amplifier and you feed it with a high frequency, it might start switching in the megahertz range, but I'm not sure about that. But for official record rules, 1 amp, 1 battery, you can't just put 40-50 kilowatt burst, you're limited to 4.5K. Dude, Matthew, thank you very much for the 10, man. That's awesome. After the repair on my RCA inputs on the SD12K Tiffany style, the amplifier ran fine for about 30 minutes until I turned it up. And then music stopped and started playing like pure tones. Oh, shit. If all you did was change the RCAs, that shouldn't have happened. If you removed the whole board from the heatsink to change the RCAs, then it's possible that there was something shorting to the case ground after a few minutes. When you put it back, there was a little bit of solder or something between the FET and the case ground. Or maybe the RCA, Tiffany style RCAs were hooked up slightly wrong and soldered to the slightly wrong, but that doesn't make sense to me. Changing the RCA connectors wouldn't generally cause a problem with the amplifier. So yeah, not too sure about that. So what is your 12 volt remote input connected? Is it connected with the 12 volts? Yes. My remote wire is connected to the 12 volts, but through a foot pedal switch. So I can turn 12 volts on and off via a foot pedal to the remote line. Your videos has recharged me to see about getting back into a bunch of fixing old school amps. Good stuff. Yeah, fucking do it, man. Jump on it. Crack on. Damn it, what does a clean head unit do for you anymore then? Yeah, nothing. Pretty much. Your subwoofer output can be clipped as fuck, and your subwoofer output from your amplifier will still be clean. Bass boost on your head unit to max, boys. Yeah, man. Fucking hell. What if you clip at the same switching rate of the amp? I'm not sure what you mean by that. Obviously I can't feed the amplifier with 125 kilohertz. Well, actually I can, because my frequency generator goes up that high, but the preamp circuit will just filter all of that out. Why does the amp convert it back to a sine wave? Because of low pass filtering. That's all it is. A sharp square wave the thing that makes it a square wave is a high frequency change in shape of the wave. So if you apply a low pass filter to a square wave, you end up with a sine wave. That's the only reason why it turns it back into a sine wave, is because the amplifier has many low pass filters applied across the amplifier. Yeah, that's not a real fire. That's not a real... That's just a fancy effect. That's not a real fire. JTR. Jack the Ripper blown away. Shit, man. Yeah. Actually, that did surprise me a little bit as well. I wasn't quite expecting it to make a clean sine wave like it did. That's pretty funny. Oh, it's an old video from your channel. Like a music video, gotta have a box. Yes, I think I remember that one. Shit, what did the lyrics go like? Shit. Okay, guys, someone that has donated... Oh, fucking hell, holy shit. PA and car hi-fi. For the 5, man, thank you very much. That's awesome. Also, got 4 BNC, 18 SW100s, 1.5 KRMS subs in my PA system, and I'm planning on building a fun enclosure for my car to run all 4. That's going to be awesome. Guys, PA audio in your car, PA subs sound amazing. Guys, do you remember, if you're long-time subscribers, do you remember my JBL 15s that I had for a long time? I blew them up a few years ago by accident, but before I blew them up, I put my JBL 15s in my car with the back seats down in the Proton, almost a bit like a wall. Almost like right behind, like on the back seats, like a wall of the 215 sitting there. And my God, the bass from, like, it wasn't low, it wasn't like hair tricking or low or bass, but the kind of bass that I got from those PA woofers was absolutely phenomenal. Like, so accurate, so clean, so punchy. Music, like actual music, sounded sick. Like, so much better than a car subwoofer would produce it. I highly recommend, if you're not looking for like 150 dBs, if you're just looking for really awesome, accurate sounding bass in your car, try a PA sub. Fucking do it. Sounds good. Joshua, thank you very much for the 10, my man. That's sick. Thank you very much. Remember the repair on the Infinity Kappa 1? Yes, I'm having the toughest time finding a replacement power adapter. The gauge wire adapter? I don't think that my amp had one of those. Let's have a quick look on here. Infinity Kappa 1. I think it was just bare wire input. I don't think it had an adapter. Oh shit, wait, maybe you mean... No, my one looked like this. Yeah, my one looked like this. It didn't have an adapter. So not sure what you mean there, buddy. But I'll try and help out if I can, if you tell me what it is I'm looking for. I'm pushing two 12-inch subs with a 300 watt mono block. Gain is turned low and I get a nice bump. Yes, you don't need that many watts. Higher power gives you diminishing gains, diminishing results, diminishing things. So like, you know, the more power you throw at it, the less percentage louder it gets for each extra watt you give it. So low power can sound great, especially in a big box. The bigger your box, the more bass you get per watt, the more efficient it is. Any Pioneer 3004 SPLs laying around? Yeah, they're actually getting quite expensive these days. I actually used to pick these subs up for like 20 to 40 pounds each, but nowadays you see them listed second hand for like 120 pounds. They get blown quite easily because they only take about 800 watts RMS, to be honest. Beverage, would you rate my amps? Wait, what? So I'll look at that later. I can't decipher that link right now. It'll take me too long. Which two-way doors do you recommend for good sound? It's too much of a broad question. There's too many options to recommend there. Sorry, buddy. Would increase the capacity on this board give more headroom for bass? I'm not sure what you mean by that. Sorry, buddy. Switching frequency is very similar to sample rate. Yes, it is. Absolutely very similar to sample rate. Loving this video. So much good information. I'm glad. It's been a lot of chatting shit. Metal oxide semiconductor. Yes. Can you send me a speaker? I'm not not doing it, broke boy. Can you send me a speaker? Not doing it, broke boy. I can send you this speaker. Do you want this speaker? I can send you this speaker if you want. Yes, they do sound amazing. Jack the Ripper, I'm just thinking, if I make 555 square wave generator with some kind of sort of whatever that amp does, will it be an ideal bench signal gen for me? Yeah, you could do. You could make a square wave, like a square wave signal generator, and you could test car amplifiers with it because it converts it back to a sine wave again. What kind of electrical system do you have in the Proton? Stock. The Proton doesn't have big bass. It just has an SQ system. I actually have 2 alternators on the Proton, but one of them is not hooked up. It's just acting as a pulley. It's just like disconnected. So I have a stock charging system with a very old, very tired battery, and that's fine. I don't have big power. I don't have big watts in the Proton. Yeah. I have an Alpine, this on 4-channel on my high, super sleeper amps. Alpine make some of the nicest quality circuits. I'll tell you that. Alpine, they're cheap to buy relative to their circuit quality. Alpine are fantastic value for money. Definitely buy an Alpine. Currently I use a JVC media player with sine tones on a USB for input signal, and it does work perfect, to be honest. Yeah, absolutely. If it works, then go for it. Gotta go, bro. Later on, man. Thank you for tuning into the stream. Law of diminishing returns. That's exactly the phrase I was looking for. Thank you very much, Midnight Express. Can you explain how you get away with not using a ground lead on your scope probe? My scope is grounded through my electrical mains to my power supply. So my bench power supply, which is this. So here's my bench power supply. My bench power supply is grounded. Yeah, so the ground is connected to the power supply negative, and the oscilloscope, the ground of the oscilloscope, is also connected to the mains ground. So the grounds are all connected together. That's why I don't need a ground lead on my oscilloscope, because the grounds are all connected together through the ring main. When do you think you'll create the Discord server? Probably tomorrow. I'll make a Discord server tomorrow. Do you recommend Ground Zero amplifiers? Some of them yes, some of them no. Ground Zero make a whole plethora of different amplifiers. Some of them are good, some of them are not so good. So I would need to know which model you are looking at in order to advise you on that. Bust out a JBL amp to work on. I was gonna say I don't have a JBL amp to work on, but I do. I have a JBL Crown A6000 GTI that's been here for over 1.5 years that I just couldn't fix. It's been 1.5 years now, so I have 1.5 years of more experience and knowledge up here, so maybe I'll try it again. But it's just sitting here looking sad in pieces, so I could do that. But I don't think I have any other JBL amps to work on at the moment. Nope. No other JBLs in here to work on, unfortunately. What FETs are you finding harder to find in the UK to complete repairs? I am finding these FETs harder to find. The MOSFETs which are in the sound digital amplifiers. CSD these ones. I am finding these MOSFETs incredibly hard to find in the UK, and these MOSFETs are required to repair sound digital amplifiers. CSD 1852 KCS. Now, who wants to learn a little bit about MOSFETs? So these MOSFETs are very special in the way that they have a very low drain to source on resistance. RDS, resistance drain source on. So this is the resistance of the MOSFET when it's turned on. We have a VGS 10 volts resistance of 2.4 milliohms. Okay, now that's pretty good. Now, in addition to this, we also have a continuous drain current of the silicon limitation at 25 degrees Celsius of 212 amps. And we have a pulse drain current of 400 amps. And we have a total power dissipation. This is basically a heat dissipation. How much heat can the MOSFET dissipate to the heatsink? Of 259 watts. So that's all pretty good. Now, the thing that makes these MOSFETs fucking really special and amazing is the fact that it can do all of this high current, high pulse drain current, low RDS, while having a stupidly low total gate charge of 52 or 62 nano charges, whatever the fuck this reading is. This is fucking low. This is ridiculously low for the amount of current and the amount of power this MOSFET is. Not only that, do we have a ridiculously low input capacitance of a maximum 6400 picofarads. I think that's the correct term. That is freaking mental. And these MOSFETs are so special in the way that they have such a high power handling and low resistance compared to their charge, you know, the amount of current they need to be charged by the drive circuit. It is almost impossible to find a suitable replacement for these MOSFETs from any other manufacturer or any other MOSFET. These are so special in the way that they have so much ability to pass current and such little requirements for drive power. It is insane. So those ones are not available in the UK. You can buy them from Mouser with a high shipping charge, but yeah, they're a little bit difficult to get over here, and that's pretty annoying. I would show you the JBL amplifier, but it's so big that I would have to clear my whole workbench to get it on here. Midnight Express says he loves the idea of having the internet fix the amplifier. Alright then, fuck it, let's do it. So one of the live streams that we're going to do in December is going to be the internet fixes the amplifier. That's going to be really awesome. That's going to be a really fun video. We'll do that at some point during STREAMMAS. So if you're not already subscribed, subscribe. If you haven't already, click the bell icon and make sure that you also go into the bell icon and click all notifications so that you know when I'm going live, so that you get notified about that live stream, because that's going to be really fun. Christopher. If you received, say, a Rockville lamp, could you improve it? Yes, I could improve it. I could improve it by increasing the number of turns on the transformer for more power. I could increase the trace thickness. I could improve the MOSFET quality. I could improve the power supply switching frequency to allow more current to be passed through the transformer. All sorts of stuff. What about Ground Zero GZCA series? Let me just have a quick look at that to remind myself. Ground Zero GZCA. What is that looking like? Oh, this is the sound digital stuff. Okay, so if you want to know what the Ground Zero GZCA stuff is like, then turn your attention to Sound Digital and look at reviews for Sound, because it is Sound Digital. Sound Digital make the amplifiers for Ground Zero in that series. I have a Pioneer that plays flat from 50 to 20, but I'm not impressed by the loudness. In a box with a 22 Hz port. Well, yeah, that's the thing. You either get loud or you get bandwidth. If you want to get loud and bandwidth, then probably build a 6th order. So build a 6th order bandpass and you will probably get what you're looking for. The square wave has my mind blown. Yeah, that actually surprised me a little bit as well. I wasn't quite expecting a clean sine wave. I was expecting a bit of a funky sine wave, but it was freaking clean. Have you ever repaired an audio barn or sound cube amp? Yes. Audio barn amplifiers actually were pretty good for their time. I repaired an audio barn amplifier recently that had a fully regulated power supply section that held a constant rail voltage, and the component quality was good. The audio barn amplifiers were actually okay. Sound cubes, it's generic stuff. Same as everything else. Thank you very much, Robert. I appreciate that. Have done that ages ago, but still never get the notification. Yeah, I don't understand YouTube. Like, so many of you guys say you never get a notification when I'm live. I can't fix that. That's the one thing that I can't fix. I can't fix YouTube's nonsense with their notification system. I'm an expert in amplifier. I fix all brands of amplifier. I learned from your video. That's awesome. I'm glad to hear that, man. I'm really glad that I was able to expand your knowledge and to take you on a new course of life. That's pretty crazy, right? I have personally influenced this guy's life choices and his life. I have changed his future by myself making videos on YouTube. I have influenced this guy's life and changed his future. Like, there are things that will happen in his life that wouldn't have happened if I hadn't have made videos. That's pretty scary. That's pretty freaking crazy. Oh, Midnight Express. CSD, would you be interested trying to work a deal getting these from, say, a person like me and having them shipped? Yeah, of course. That would sound great. At the moment, the cheapest place that I can get those FETs is Mouser. If I just go ahead and copy this KCS and just have a quick look on Mouser UK. Shit, I don't need to bookmark it. TI, all transistors, Mouser. Let's just go to Mouser UK. So at the moment, the best price that I can get these bad boys shipped to the UK. At the moment, I need 20 of them for a repair that I am working on. So if I enter quantity of 20, actually I think I have, no, I thought I put them in my basket. View basket. Then if I go to checkout, yeah, so the FedEx International Priority Shipping is £12. So the total cost for 20 of these CSD MOSFETs is £41.80, which is quite a lot. So if we can work out something where I get them cheaper than that, then yeah, I'm all ears, absolutely. Perry hates Audiobarn. He probably hates Audiobarn because it's very flashy. I mean, okay, Audiobarn is not the best quality stuff, and they have made some shitty amplifiers, but I've repaired a few Audiobarn amplifiers that, for the time, weren't too bad. They weren't so bad. They were generic circuits and stuff, but the build quality was not that bad. And they looked fucking awesome. Back in the early 2000s, like, who didn't want a chrome, flame, plated, fucking, flamey, chromy, blue LEDs? Like, everyone wanted that shit. I wanted that shit. I remember looking through Max Power magazines, looking at the Audiobarn stuff, and I was like, yeah, I'll have one of those, I'll have one of those, I'll have that with the blue flames and the chrome flames, I'll have one of those. The photo, it shows the adapter. It looks like a double 1/0 power adapter. The model is Infinity Kappa 4, the older model. Okay, let's have a quick look at the Infinity Kappa 4. Infinity Kappa 4. Let's have a quick look at that. Images. Still not really seeing what you're referring to here. That one looks like just regular inputs. Infinity Kappa 4 has the regular inputs now, so I'm still not too sure what you mean there, buddy. Tony DeMoore Class A amps. Haven't seen them. I don't know. Tony D'Amore, whatever you want to say his name. He is a class engineer. I don't know whether I would get on with him on a personal level. I've never spoken to him. He definitely seems like the kind of guy that knows that he's good at what he's doing. So he doesn't have time for noob questions or bullshit or like anything like that. Which is okay, I guess. Like, you know, he's an older guy and he knows what he's doing. He knows his shit. He's an engineer. He designs his own circuits. He's far greater than I am. Like, absolutely skyrocketing better than I am in terms of circuit design and stuff like that, amplifier design. I would imagine that his amplifiers are fucking awesome, but I haven't seen any, so I can't comment. And even if I did see some of them, my knowledge on Class A is not that great, so I probably wouldn't be able to tell you whether it's any good or not. So, yeah. PA cones are great for music, for sure. Look up the Audubon Immortal subs. They are the coolest subs. Yeah, I agree. Like, dude, man. Like, no one makes subs like this anymore. Audubon Immortal. Like, nobody makes subs that look like this anymore. All the subs that you see these days, it's a TI basket. It's the generic basket. It's the same old shit. No one makes subs like this anymore. This is so sick. This looks so good. Like, okay, it looks kind of tacky now, but like, at the time, this was the stuff. This was, I mean, fucking hell, look at that. Look at that sub. It's fucking beautiful. They custom tooled this whole basket. They custom tooled this whole thing to be what it is. They custom tooled all of this flamey shit. This is sick. This is really awesome. Like, yeah, they may not be the best subs in the world, but man, I have mad respect for making something unique, making something that's like stands out there. It's different. Like, yeah, it's not cool these days. It's not cool these days, but man, in the late 1990s and the early 2000s, this was freaking cool. This was ballin' ass. If you had a pair of these poking out your trunk, invert mount in a fiberglass, shitty designed boot install with a couple of Audubon amps and a couple of Clarion screens or something, you were right up there. You were fucking doing it. You were doing the car shows. Who remembers these subs? Who remembers, wait, where is it? Where the dual suspension, who remembers these? These were pretty cool, right? Monocore, they had like a spider suspension system on the back of the motor. Why can I only find that picture of it? Oh, it was a Raptor, that's it, Monocore Raptor. Let's have a look at these. These were really cool. Who remembers these from YouTube? These were cool things. I remember seeing YouTube videos of these. I have no idea how good they actually were because I couldn't afford them when I was like 14. But yeah, these definitely sparked my interest. Like, who doesn't want a fucking subwoofer with a spider on the back of the motor? They looked cool. There's some YouTube videos on them as well. Let's have a look on YouTube. Let's have a quick look on YouTube. Let's check out some videos of them. Monocore Raptor. Let's try and get, there we go, mini car power. Here we go, car power mini subwoofer. Let's get the desktop audio. Like a crazy rumble, like a crazy rumble, like a crazy rumble. Like, you can't tell me that that looks freaking cool. That does look cool, doesn't it? How freaking cool is that? How freaking cool is that? And you got the, oh look, oh fucking hell, here's one of my videos. Fucking my own video here. Wait, what the hell is Mango Electronics? I must have written that. That must have been where the video was taken from. Long through. Let's skip on a little bit. Here we go. The rear spider at work. Let's see if there are any other videos of these subs putting in some work. No, that's my videos again. That's boring. No, there's not that many videos of these on YouTube, you know. Let's check out this one. Oh, it's Bass, I love you. It's Bass, I love you. Yeah, I mean, okay, it's not the longest through subwoofer ever, but it's pretty cool. One more. Let's have a look at this guy. Does he show the sub? No, he doesn't show the sub. Okay, never mind. But yeah, I thought that was pretty cool. I thought those subs were the coolest thing ever when I was like a young guy. Oh, rotary subs! I just saw the word rotary. I don't know where I saw it. Rotary subs. Yes! I remember seeing the video of the rotary sub playing like 3 hertz. And it was like... crazy shit, man. From an engineering perspective, what amps would you say are high quality? Alpine. Oh shit! Some shit just fell over in the workshop. Did you see that? Alpine. JBL. Rockford Fosgate. JL Audio. Alpine again, because they're sick. Engineering perspective. To be fair, Audison, pretty good. Audison makes some pretty awesome amplifier designs. I think some others. Let's have a look. What else we got? Genesis. Okay, so the Kicker Warhorse was a bit of an engineering feat at the time. Yeah, so the Kicker Warhorse is a fucking terrible amplifier these days, but at the time it was an engineering masterpiece. So it depends what time period you're talking about. DLS basically fucking copied Genesis. DLS is Genesis. Peerless Timpani subs. Yes, Peerless Timpani. I know that they are home theater sub stuff of dreams. They're really fucking cool. By the way, your videos have inspired me a lot about building that Pioneer sub for my home theater. Yes, and such. And by the way, are you still using the 4 KEFs? No, the 4 KEF speakers are actually... I forgot about those! The 4 KEF speakers are under my bed. They're actually under my bed, stored away. They're waiting for me to build them into something. I haven't decided what I'm going to build them into yet, but I'm building them into something. But yes, that is what's happening with those subs. Orion is good quality stuff. Yes, Orion stuff, the modern stuff, it is up there with some of the best for loud SPL, DBs, etc. It's pretty good. Okay, guys. Guys, it's been almost 3 hours. I think it's about that time to lock it off for the evening. I would like to thank you all so fucking much for joining in on the live chat, having a talk with me, asking so many awesome questions, throwing in some donations. Like, you guys have been dropping bombs on the donations all evening. Thank you so much. I don't expect that at all. So it's really a big surprise when you decide that you want to throw some dollar my way. It like really surprised me. Thank you so much. And remember that we are live streaming every single day in December. So you will catch me live again tomorrow about the same sort of time, maybe about 10 p.m. UK time. I will put a scheduled stream reminder in advance tomorrow so that you'll know what time I'm going live. And tomorrow is a Sunday. And my soldering line tip won't have arrived by then. So I don't know what we're going to do tomorrow. But if you've got any ideas of what you would like to see me do tomorrow, then make sure you send me a message. Go to Facebook. Type in BearVids in the search bar of Facebook. And send me a message. Tell me what you would like to see tomorrow in the live stream. And we will do it. We will do it. Perhaps tomorrow we can look at the audio pipe 3K that I'm doing in the for Derek Wilson Audio Labs. We can take a look at that, see how far through that modification I am. We can look at a few other bits maybe. Like again, I haven't got a soldering line, so I can't solder anything until my new tips arrive. But if there's anything that you'd like to see, let me know and I'll do my best and we'll do it. Play Xbox. I don't have an Xbox. I'm a PlayStation man. The time currently in the UK is midnight. 8 minutes past midnight. Can you do the same thing? I have so many more questions. Yeah, I could do the same thing. Tomorrow, yes, I will start a Discord tomorrow. We'll do a Discord. Yes, that's absolutely fine. Thank you guys for being here. I really appreciate it. It's awesome. Even though in the UK we're in like tier 3 lockdown, I feel like I'm connecting with the humans. I feel like I'm connecting with you guys, and it is fantastic to chat about audio, chat about electronics, chat about the shit that I'm passionate about. It's really, really awesome. Car audio bargain 1600.1D. Wow, that many watts? That's fucking awesome. What do you currently have in the T-lines? I don't have any T-lines in my bedroom or home setup. I sold... Actually, I think I gave them away. I think I gave those T-line floor standers away. I needed the space. But when I get my new house, T-lines for days. Don't worry. I said that I'm a PlayStation guy, but I didn't mean that I'm a current PlayStation guy. I game right. Fucking hell. Any of you guys are gamers? Any of you guys like playing Xbox, like playing PlayStation, like computer gamers, Computer Master Race, PCMR, Steam? Guys, please tell me if any of you guys that are my friends on the audio scene, on the live chat, if any of you are into VR, please hit me up. Message me on my BearVids Facebook page. I am dying for some friends to play VR games with, like fucking can't think of any right now. But basically, I don't really play many games on computer games. I have a PS3 that I use for Blu-rays. I play PS2 games on my computer with the emulator. I play Nintendo Wii games with an emulator on my PC. I have my girlfriend has a Nintendo Switch and I play Mario Kart 8 Deluxe. That's pretty cool. But I fucking love VR. I have a Pimax 5K Plus VR headset. I have a 1080 Ti. I have a 4790K processor, which is a bit old now, but it still does the job. And I play VR games. If any of you play VR then let me know and we can jump on and play some VR together. I would fucking love that. There's probably not going to be anyone here that plays VR, but even if there's one person, that's awesome. But I don't have a PS4, I don't have a PS5, I don't play PS3. I play VR. So if anyone plays VR, then hit me up. It's... Dude, like if any of you guys haven't tried proper VR before, your wormhole is about to be blown out of the next fucking galaxy. It is the most insane thing I have ever experienced. Honestly, it is so freaking crazy. When you get proper VR, like Pimax, Index, I think the HP Reverb 2 is pretty good as well. PS4 VR doesn't really count. That's not really proper VR. It's okay, but it's not proper VR like. James B has Oculus. Okay, sick. Maybe we could play some PokerStars VR. Maybe we could play some there's one with the bow and arrows. I can't remember what it's called now. Maybe we could watch some films in big screen VR. With VR, you can actually watch films in a virtual cinema with other people around the world in person. You can sit next to somebody in VR and have their avatar in VR and talk to them and watch a film together. You can watch videos on your PC together. There is so much going on with VR at the moment. You need to jump on it if you haven't already. James B has Oculus. Maybe we could jump on and do some stuff together. RTX. I need an RTX 3080. Absolutely. I can't buy one anywhere. They're all fucking out of stock. Fucking scalpers everywhere. I have never played Beat Saber yet. Well, I know. I played Beat Saber one time at my friend's house with Oculus, the version 1. Yes, I need to play Alyx. I haven't bought it yet. I was waiting for it to come on sale. Haven't bought it yet, but I know that that's a sick game. VR chat is popular, but I know that it's really cringy. Like, it's basically full of kids and furries and stuff. So I could try VR chat, but I know it's a bit cringy. But guys, I'm sorry. It's that time. I have to jump off the stream. It's gone midnight and I am due for going to sleep. So, thank you so much guys for joining me on the stream. Really appreciate it. I will see you all tomorrow. If you missed the stream this evening, jump on, catch me tomorrow, and we will do some more shit. I'll try and do some repairs. I do have a soldering iron tip, but it's this really thin ass tip. It's this really... It's this thin, like, sharp tip, and it's really difficult to solder, like, amplifiers with. So I'll try and do some repairs perhaps, but can't promise anything. But yes, guys, thank you so much for joining me on the stream. I will catch you tomorrow. It's been amazing. Thank you very much.